What's up, Pie-Eyed Piper? Terry Hayes, good day. What's up? Salonelian, what's up? Fred Carr, One Man, what's up? What's up, everyone? So, I'm a little excited today. So I'm trying something different now. Again, that doesn't mean I'm gonna abandon the 2 questions or asking questions, but I just thought I'd do it a little bit different this time. See how it goes. So, in this video, I guess, right? I was gonna say episode. In this episode, in this video, so I made, for those of you who haven't seen this, I showed this in my last live stream, but for those who haven't seen this, I made an accelerometer, a simple accelerometer. So again, I have a container filled with water, and I have a buoyant object inside. So it's a red plastic ball, as you guys can see, right? So this is a simple accelerometer. And why is that? Because the ping pong ball, or the plastic ball inside the medium we call water, will always displace when you accelerate this container, 100% of the time. Like, there is no escaping that, right? So as you guys can see, like, once it's completely still and I move it or accelerate it in any direction, left, right, front, back, the ball will always react. Again, because for every action, there's an equal and opposite reaction. So again, the cause being acceleration, and the effects of the acceleration are displacement. So again, the ping pong ball will always displace 100% of the time. So for this challenge, I'm gonna have to move this a little bit. There's my so for this challenge, the challenge is, so again, I have my sign right here. I'm gonna bring it out in a bit right now. So it's $100 challenge, right? Because what college student couldn't use $100, right? So I'm doing this also to, like, draw more attention, maybe get more people coming to the table. So I'm gonna be bringing out the $100 challenge sign right now, but I just wanted to give a quick overview of what it is. So the challenge is gonna be, my table is only 4 feet in length, right? So what I'm gonna ask the students, what the challenge is if they can accelerate this a distance of 2 feet, which is half of my table. So if you can accelerate this a distance of 2 feet in 1 second without displacing the plastic ball, then you win the $100. It's literally that simple. So that's the challenge. So what it's gonna be, again, once it's completely still and at rest on the table, all they have to do is accelerate this 2 feet in 1 second without the reaction of the plastic ball, and you win $100. Literally that simple, right? Should be pretty easy, right? Well, we all know that that's physically impossible, right? So it's a win-win from my point of view. And if you ask me, it's a win-win for the people coming up to the table too, because they're gonna gain some knowledge at the end of the day, you know? So it's a win-win regardless. Point being is that once I get students to accept the fact that it's impossible to accelerate the container without the reaction of the plastic ball within it, once people accept that and understand that, then that's when I'll bring in the question about, well, do you guys believe objects accelerate down in free fall? Because when I actually accelerate again, this displacement always happens. Oh man, I didn't want to put that. Let me go back. Let me remove that. That was another GIF for another time. So again, whether I accelerate right, accelerate left in this case, or whether I accelerate right, again, the ping pong ball and the steel ball will always react to acceleration. Why? Because those are effects of acceleration. So if you claim acceleration, then there needs to be effects. So matter has to react to that acceleration, right? Because that's what happens 100% of the time when we introduce a force to solids, liquids, and gas. We get a displacement, we get a reorientation of matter relative to the direction that the force is being applied. Buoyancy showing the direction the force is being applied. This is physics. This is 100% true, factual. Anybody can repeat this. Anybody can demonstrate this to themselves, and it will be true 100% of the time. So when we're talking about downwards acceleration, don't tell me I don't have it. I should have it. Let me add it. No, it's not that one. Oh, it's this one and this one. Okay. So when we're talking about downwards acceleration, the buoyant object should get pushed down in the direction of acceleration, and the dense object should move in the, or appear to move in the opposite direction of acceleration. Again, so when we're talking about downwards acceleration, which one of these two is accelerating down? Again, based on the principles of displacement, based on the fact that there needs to be an effect of acceleration, again, a reorientation of matter, right? The ping pong ball will always show you the direction of the force, right? So in this case, which one of these two is being accelerated down, right? It's literally that simple. Which one of these two is being accelerated down? All you have to do is look at the ping pong ball relative to the medium that surrounds it and see what direction the ping pong ball gets pushed in. So in this case, obviously, it's the one on the right. The right is the one that's showing the displacement. Again, the one that's showing the reorientation of matter. Now, the more dense goes towards the top of the force, and the less dense, the buoyancy, goes towards the front. Because buoyancy is a push, again, at the end of the day. The one on the left is not accelerating down because there is no effects of acceleration. There is no buoyancy, there is no density, there is no pressure. There is no effects of a force whatsoever, no effects of acceleration. So the one on the left is free falling, but we know based on how matter reacts that it's not accelerating down. Again, when we actually accelerate it, like the one on the right, we can clearly see the displacement of matter. So that's the reality. So I'm gonna go ahead and bring out the sign already to see if anybody wants to come up and try the challenge, and we'll see how it goes. What does it look zoomed in? Oh my god. I was like, why does it look so zoomed in? Alright, I'm gonna bring it out. It's just one simple challenge if you wanna give it a shot. $100 challenge.
What do I lose?
You don't lose anything. You can only win.
Let me see the money. I'm joking. Come on, what's the question?
Alright, so
Luke Swanson, Luke LUKESWANNN on Instagram.
there you go.
What's the
All
question?
right. So,
And that's my Venmo.
so the challenge is, do you know what this is right here by any chance?
It's an illusion.
It's an illusion. Why do you think it's an illusion?
Because why is there a stick with a ball sticking out of it in a? Is that water?
Yeah, it is water.
Yeah, and water. That don't make sense.
So, do you know what buoyancy is?
No.
No, buoyancy is when something floats in water.
Okay.
Right? So this is a buoyant object.
Yeah.
Right? It's in water. It's buoyant. So the challenge is, well, let me just show you. No matter what direction I accelerate this,
Yeah.
the plastic ball will always react to that acceleration. It will always get pushed in the same direction I accelerate. You see that?
Yeah.
It doesn't matter what direction I do it. Always, 100%. So the challenge is, if you can accelerate this container
Without
from
moving the ball?
here to here, only 2 feet,
Without moving the ball?
without moving the ball, you win the $100. You want to give
Does
it.
it have to stay on the table?
It has to stay on the table, and you have to accelerate it from here to here in 1 second, without moving the ball. Can you do it
1 second?
in 1 second? So a distance of 2 feet in 1 second, without moving the
Are
ball.
you sure? Can I touch the water?
Well, I mean,
That ain't water. On
that
the
is
top.
water, 100%. It's not a trick. It's not a trick. It's water, and it's basically you can call it a ping pong ball.
Okay.
It floats on water. So that's all it is. I put the wood here just to hold it, because I tried using glue, and the glue with
There's
water.
a way to do it?
Well, I want to see if you could do it. I want to see if it's
Well,
possible.
can I see you demonstrate how the ball moves again?
See that? It always reacts, even to the slightest, right? Right? You think it's possible? I guess let me ask you. You think it's possible to accelerate this to this line in 1 second without that motion of the bubble? I mean, of the ball.
Unless my hand's in the water.
Right? No, but just like this.
No.
You didn't think it's possible?
No.
And you're actually right, because this is physics. You
not
can't break
possible.
physics. It's like me asking you to fly, right?
It's not possible.
So, because this device will always react to a
always gonna
force.
move,
Exactly. So let me ask you this. This is why I'm doing this.
Yeah.
If I release this into free fall like that, do you believe this accelerated down to the earth?
Say it again. Wait,
When I have this,
Gosh,
when I
can't
have
do
this right here,
Yeah.
and then I release it, do you believe it accelerated down to the earth?
Gravity.
Yeah. Do you believe gravity pulled it down
Gravity.
to the earth? Okay. So when I actually accelerate versus free fall, let me show you this, because
It actually might stay still free fall versus acceleration.
so here it is. So I accelerated one of these. Can you tell which one I accelerated down? The one on the left or the one on the right? Which one did I accelerate down?
When you say accelerate, you mean
Like actually accelerated down the ball.
push down?
I actually pushed down. Which one did I push down? Which one did I accelerate down? The one on the left or
This
the one
one
on the
you
right?
push down.
The one on the right. Exactly.
This is free fall.
Yeah. So here's the thing. The one on the right clearly shows that there is acceleration,
Yes.
because for every cause, there's an
There's
effect.
effect.
Exactly. So displacement is an effect
But
of
if
a
it's
force.
free fall,
Free fall.
there's no cause.
Exactly. They claim that there is a pulling force of gravity, but the fact is there is no effects of a force in free fall, because there is no effects of acceleration in free fall. Because again, the ping pong ball will always get pushed in the direction you accelerate it. You can't escape it. That's a fact. I don't know if you knew gravity is just a theory. So the reason why is because it has never been physically proven. So a physical downwards acceleration of matter has never been
So
actually
if I
proven.
jump off a cliff, will I die?
So what happens is everybody believes the Earth is pulling you down towards it, right? The fact is the Earth is pushing up against you.
Oh.
Yeah. So if I was, again, because the ping pong ball will always show us the direction of the force when it's inside a medium, what direction is the ball being pushed right now?
I didn't see it.
No, right
Now
now.
you can tell.
If I was to cut the string, what direction would the ball go? The
Ah!
Earth is pushing it up. So that's the force. So when you fall off a building or you jump to drop, it's not you accelerating down towards the Earth, it's the Earth literally catching up to you.
Damn.
That's the reality.
So dead as hell.
That's a fact. So let me ask you this. You believe the Earth is a ball, right?
I believe the earth is flat. I'm joking.
No.
I wish y'all saw this reaction. Okay, go.
You got my reaction there. So you believe the Earth is a ball,
Yeah.
right? So if up is relative on a ball, meaning if you're standing here, up is this way. If you're standing here, up is this way. It's relative to where. And if we could prove that objects don't move down towards the Earth, and it's the Earth literally pushing up against you, and up is relative on a ball, how would that work if the Earth is moving up? If we're on a ball, the fact is it wouldn't work, because
Yeah, I was gonna say,
it would have to be expanding. So this simple fact, the fact that there is no gravity of a pull, debunks or
Gravity.
proves that there is no, that it's impossible for us to be living on a ball.
So
the
the
globe
earth is
Earth,
flat.
Well, it's not flat either.
Dang it.
I'm gonna tell you why.
Triangle? What?
Over 95% of flat earthers claim the Earth is motionless. So what does that mean? They also believe in.
Well, I just said it because Kyrie said it.
Yeah, no, but they believe in a pulling force of gravity as well. So they're perpetuating this idea of objects accelerating down, which is keeping the whole globe Earth idea alive. So these flat earthers online, I call them mainstream flat earthers, are no different than globe earthers. The fact is the Earth is level, and it's level again because you can't have orientation without a force, right? So the Earth is level because it's literally pushing up right now. It's literally moving through space like this. And that's what makes it level. Level is perpendicular or relative to the vertical, which is the Earth's motion.
I just won the challenge.
So let me ask you this: you've heard of flat Earth before, right?
Yeah.
So what do you think about the subject, or what have you heard about it?
I don't think the world is round, and I don't think it's flat.
Okay. Okay. So you don't think it's round? That's good. So you're open to understanding more. Do you want to know something? Another main proof besides?
$100.
Well, you didn't accelerate. That's impossible. So before you go, real quick, just before you go. So the Earth, the globe Earth, they claim to have satellites orbiting, right? NASA claims to have satellites orbiting. So based on the radius of the Earth, there needs to be curvature every mile. Every mile there needs to be curvature. But if you understand the physics of water, again, water is going to show us that that when water is level and contained, it's impossible for it to be a globe. So if we went to a lake, which one of these two represents the surface of the lake? You think this one?
Boom. Am I wrong?
Nah, the fact is this
What?
one. This is real physics. Water level doesn't have the ability to hum when it's contained, like the surface of water.
Oh, yeah, wait, I actually didn't know.
Yeah.
So
So
this is not moving.
exactly. Yeah.
What's your name?
My name is William.
William, thank you so much.
Yeah, no problem. Here, let me give
So
you my
what's
channel.
the Earth?
The Earth is a level plane. It's
Perfect.
a level extended plane.
I'll just start telling people that.
It's not a globe.
Thank you
All right,
so
man.
much.
Take care. All right, that went pretty decent. Went pretty good in the beginning. Then kind of didn't have anything prepared for after the challenge. So I kind of just freestyled it there for a bit. But he didn't even try the challenge. He understood that it was gonna be impossible. Yeah, he didn't even attempt it because obviously him seeing me do it and then always happening, even with the slightest movement, he realized that that's impossible. In other words, so yeah, I think it's gonna be good. So again, that was just literally the first conversation with this new challenge right here. Yeah, we'll see how it goes. I want tea, Skilly Wonka, Papa Will. What's up, everyone? Yeah, I kind of have to hold the sign. I kind of wanted to leave it leaning on something like my water bottle, but you know what? Maybe in the future, what I can do. What I'm gonna do is pull Velcro on this and pull Velcro on my bottle, and then just stick it to it like that. And that way I could just have it in front of the table like that with my bottle with some Velcro. Can't believe I didn't think of that. I guess for next time. That way I can still be hands-free talking to the table while the sign's being displayed. Because I could lean it right now, but any little gust of wind, it's gonna blow it away. So, damn, I should have brought that Velcro. For sure next time. And I didn't even get to highlight the fact, because everybody jumps to that explanation. It's kind of like a default explanation when confronted with these facts about no displacement and free fall, is people literally go to, well, it's all being accelerated together, right? It's all being accelerated at the same rate, and that's why there's no displacement, right? Well, guess what? That kind of force that can accelerate an accelerometer and the accelerometer not detected, that kind of force doesn't exist. So, I mean, people could believe that at the end of the day. People can believe in Santa Claus, right? But reindeer can't fly. The whole idea of Santa Claus defies physics. So the whole idea of objects accelerating down in free fall also defies physics. So it's not real, it's fantasy. It's just based on optical interpretation of objects appearing to move down. But if the Earth was moving up and the object was decelerating, we will get that exact visual, that exact same visual, in other words. The object appearing to go down because, again, it's slowing down. It's not accelerating down, it's slowing down from the constant upwards motion. And since we're connected to the Earth when we release an object into free fall, we appear to be, the object appears to be moving down because we are moving up with the Earth. You know, that's the facts. That's the fact of the matter. I think that's where the phrase comes from, right? The fact of the matter is that matter always displaces when there's a force present. That's the fact of the matter. You know, matter doesn't lie. You know, it's about understanding how matter behaves, because that matters. My bad, I'm just having fun with all these puns, huh? But jokes aside, I mean, that is the fact of the matter. You know, you have to understand how matter behaves. You know, that's reality. Somebody telling you something contrary to that, you know, then they're full of shit. Especially if they don't have a practical demonstration of that claim. So again, it's literally that simple. Fuck, put my sign down. See, I have to have it Velcroed, because I'm gonna forget to just keep holding up the sign like this. But we'll see if people wanna give it a shot. I know a lot of challenges that I've seen on YouTube. Most of them are impossible. Like I've seen like lifting up Thor's mug, right? It's like a mug that's 100 pounds, but you have to lift it with one hand, right? I've seen that challenge before, and again, they're almost impossible, but I've seen people actually do it. You know, they find different techniques of how to lift it, how to position their hand to be able to lift that mug straight. You know, I've seen people do those challenges. The fun thing about this challenge is that it's 100% impossible. So that's kind of like, it's kind of like a trick challenge, I guess you could say, right? Because a lot of challenges seem impossible, but can be possible. If you really like doing a 20 pull-ups, right, type of thing, or 100 pull-ups, right? For an average person, that would be impossible, almost pretty much impossible, right? But somebody that works out lightly will probably be able to do it, right? But again, most of these challenges are not going against physics. That's the thing. You know, they might seem impossible because, again, our bodies have limits, but some people can push their bodies to higher limits, right? So that's the difference. With this challenge, it doesn't matter what your limits are mentally or spiritually or physically. Like, it doesn't matter what your limits are. If you think you have unlimited, if you're limitless, right, you're not going to be able to accelerate this without displacement. So it's a win-win at the end of the day. Again, it's mainly just to get people up to the table to just talk about this. Just coming up with different ways, you know. So hopefully we'll see. Make sure I'm recording. That would suck if I'm not. Yeah, the other guy seemed interested at first. He kind of understood it. He gave me like that light bulb moment look, but then for some reason he completely checked out. Like, again, and I get it. People have a very short attention span. Again, I'm not saying this to insult anyone. It's just a matter of the fact, right? It's a matter of fact. But yeah, so you kind of have to be. Again, I guess just different people are gonna have different attention spans, you know. So I mean, can't really help you there, right? I can only do my best to try and make this as fun as possible. But if you still can't pay attention, if you still can't find or see the significance in this lie, even if you still believe in the globe, the fact that people are questioning the globe and the fact that there is proofs to debunk that, and people still ignore it, then I honestly can't help you. I can't help you care about truth at the end of the day. You know, that's something that you need to... Oh, hey, listen. You want to give this a chance? Yeah, so the challenge is... Let me just explain it real quick. So you know what I have here? You know what this is? Let me see. There's water in there. Just so you know. So this is a buoyant object.
Yes.
Right? Obviously, right? So this will be considered a simple accelerometer. So an accelerometer detects acceleration. Okay. So the challenge is, when I accelerate this, you know, the buoyant object always gets pushed. It always moves in a direction I accelerate. You know, always, 100% of the time. So the challenge is, I want to see if you can accelerate this container from there to this line in 1 second without that moving, without the ping pong ball being pushed. You think you can do that? If you can accelerate that and the ball stays exactly how it is right now throughout the whole acceleration, you win the $100.
You said to this line right
to
here?
this line right here.
Specifically within this...
Yeah, so you have to literally move it from here.
So if I move
to
this
here,
entire table right now...
No. You have to accelerate this vessel.
Would that not be accelerating it though?
No. If you're moving this table, you're not accelerating this object. I want you to accelerate this container to this line. In other words,
line?
2 feet, because this is a 4-foot table.
Okay.
I'm literally simply asking for literally under 2 feet in 1 second without the ball moving. You could give it a shot. You can give it multiple.
So you already said that when you it's gonna move.
So once it's completely at rest, I want you to move from there to the line. I mean, it's moving.
It's moving. You said not in this direction though.
No. Well,
No?
it's not accelerating either, and you need to have 1 second.
So move it without any acceleration whatsoever. Well, I mean, to accelerate it without any movement whatsoever.
Would you say it's impossible? I guess that's my point. Or do you think it is possible?
There's definitely a way it's possible.
You think it is possible?
Yeah.
How can you accelerate this 2 feet in 1 second without? How do you think you can do that?
The same way that whenever you're in a plane, you're flying, you're not accelerating. So if there's got to be...
Yeah, if it's at a constant, I agree. Yeah. It's going to stay centered. But I'm talking about acceleration. From being at rest...
From rest
to 2 feet in 1 second. From at rest, 2 feet in one... Because that will happen in an airplane. That will happen in a car.
I don't think that... No,
it's not possible, right? Yeah, the fact is it's not possible. It's like me asking you to fly.
Yeah, it's not possible.
This is physics.
I was about to say, yeah,
yes.
From rest it's not possible.
You cannot break physics. So let me ask you this. If I'm holding this and it's at rest, right? Mm-hmm. And I release it, do you believe it accelerated down?
Yeah.
So
let
me show you, because the ping pong ball will always get pushed in the direction of acceleration even when I accelerate down. So when out of these two, which one did I accelerate down? The one on the left or the one on the right? Which one's reacting to the acceleration?
Is this being dropped from something?
So both, they were both at rest, but one I actually accelerated down and one I didn't. So which one?
Because they're both in water, I would say the one that
accelerated down
was this one, the black ball.
No. So the ping pong ball is red. The ping pong ball is the buoyant object is red. And if we understand that the buoyant object always gets pushed in the direction of acceleration, right?
Okay, yeah.
If I'm accelerating
downwards.
Exactly,
Yeah.
because the ping pong ball is getting pushed down, right? So the one on the left is actually free fall. And what that shows is that there are no effects of a force. There are no effects of acceleration. So I don't know if you knew gravity is just a theory.
Gravity's just a theory.
Yeah, so what that means is that it has never been physically proven. And the reason why is because there is no physical downwards acceleration of matter. Matter shows that when you release an object into free fall, it's not accelerating down. Because the ping pong ball will always get pushed in the direction of acceleration, and that doesn't happen in free fall. The fact is, I know we all believe that gravity is a pulling force that pulls you down to the earth, but the fact is that the earth is pushing up against you.
Yeah, it's a pushing force.
Yeah, so that the Globers calls it a normal force, but they don't talk about how it actually works.
Okay.
So the earth is literally pushing up against you, moving through space. So if I was to cut the string, what direction will the ball go? What direction will the ball go? That will show you the direction of the force.
I would
go
say
to the top.
Yeah,
exactly. So that shows you that the earth. Again, we understand that inanimate matter cannot move on itself, right? It requires an external cause, an external force. So if the ping pong ball is getting pushed in that direction, what's pushing it in that direction? The water, right? So what's pushing the water in that direction? The bottle. What's pushing the bottle in that direction? The table. What's pushing the table in that direction? Exactly. So you believe the Earth is a ball?
I believe it's a sphere.
Yeah. So if we can, if up is relative on a ball, right? If you're standing here, up is this way. If you're standing here, up is this way. So if up is relative on a ball, and we can prove that the Earth is literally pushing up against you and it's not accelerating objects to the Earth, how would that work from a ball Earth? If the ground is literally moving up, how would that work?
Can you ask the question again?
So if the Earth was a ball, right, and up is relative on a ball, and we could prove that the Earth is literally pushing up, how will that work from a globe? If the Earth was a globe, if the Earth is moving up. The fact is, it wouldn't work. That would mean the Earth will have to be expanding, growing, so it could compensate for that upwards push. So the fact is, the Earth is not a globe. And people have to believe in this downwards acceleration before they introduce this model. So the number one proof that debunks the globe is that the Earth is literally pushing up against you and it's not pulling objects to the ground. So that pulling force of gravity doesn't exist.
The thing is, how do I explain this? Have you ever looked down the ocean?
Oh yeah.
And if you look down, then you can see sleepness on the curve.
No, I see a horizon, which is
But it
horizontal.
drops off at some point, right?
That's our limit of perspective. So there's a limit
But
to how far.
people have.
No, people disappear over the
No,
horizon.
our limit of perspective. But it's because we can't see past that depth.
Yeah. So they're
Why
telling
can't we
us,
see past that depth? Because it's starting to curve.
well, it's because we have a limit to perspective. So the horizon is simply because the
It
horizon
only exists because we see it curve.
So I'm going to show you how the horizon is not actually a physical thing, it's an apparent thing. Because if you're standing here, and it was obviously we're in the ocean, and your horizon is at 6 miles, from the same distance, if I just elevate above you, the horizon extends further.
But why is it that whenever I'm running, right?
Yeah.
And I look 6 miles ahead, I can see 6 miles ahead of me.
Well, it depends if an object is taller than
But then
perspective
that
allows.
means that it's curved then at some point.
No, what happens again is
Because
perspective.
then if it's something shorter, then that means it's curved.
So if I move this water bottle away from you, would you agree that it shrinks the further it gets away from you? It appears to shrink the further something gets
That's
away from
only
you?
because the way that it reflects on my pupil.
Exactly, that's perspective. So we have a limit to how the angle of light enters our eye. We can't see forever. We're not Superman.
Yes, we can't see forever, but what I'm saying though is that you can look at, you don't have to be able to see forever. I'm just saying that if you look in the distance, then you can see a curve.
Well, here's the thing. So you know the size of the Earth that they claim that the Earth is? Because NASA, they claim to have satellites orbiting the Earth, right? So they need to know the radius of orbit. So they do tell us the radius of the Earth.
The only way that
So this is the radius of the
gravity
Earth.
would tend to work is if there is a sphere. It wouldn't work if the Earth was flat.
But that's the thing. Gravity is not a pulling force. It's a push, not a pull.
It's both.
It's not both.
It's both.
Well, if you're saying,
gravity is acceleration, right? Acceleration downward.
so acceleration is a
Acceleration
cause.
toward the Earth.
Yeah.
So it doesn't matter at any point. There's acceleration toward the Earth.
But simple accelerometers will not detect that acceleration in free fall. Why is that?
But that's because it's in free fall.
But why?
Look at
What's
your
what's the difference between acceleration in free fall and acceleration in any other vector? What's the difference?
Because right now, gravity, I'm not falling from. You see how there's no space between my feet and the Earth?
Right.
Whenever there's space between, now there's even more acceleration. Does that make sense?
So here's the explanation from a globe Earth.
Right now I'm not in acceleration. Right now I'm stagnant.
you're at rest. Yeah,
I'm at rest.
Yeah, at rest. So
Right?
here's
so that's different from being at free fall.
So let me ask. So the globe Earth, they claim that when you release this into free fall, gravity is accelerating all the matter inside together. That's what they claim. That's why there's no displacement. But if I was to ask them, well, how did you prove that this kind of force that can accelerate this without displacement? How did you prove that force? Like, can you recreate that force? And the fact is they can't. And that's why it's a theory. So they're just taking that visual phenomenon.
But it's because it's in water. There's buoyancy in water.
Exactly. So I can reorientate buoyancy by changing the direction of the water.
But I'm saying if you're not in water, obviously when you're in water, there's going to be some sort of.
What direction does a helium balloon go?
The helium's going to go up.
Same principles. The helium is lighter than
But
air.
that's
Just
gas.
like
You're talking about other substances other than air.
put it this way: solids, liquids, and gas, which are the three states of matter,
Yes.
will always reorientate relative to the direction of the force.
Yes.
So the more dense will go to the back of acceleration, and the less dense will move to the front of acceleration.
Exactly.
Exactly. So right now, where does the dense go? Down. Where does the buoyant go? Up. That's telling us that the force is up.
because there's another force within this that you're not seeing.
So here's my thing. When the ping pong ball is getting pushed up, the only way it's able to be pushed up is if the water's also moving in that same direction through space. The water cannot be motionless and still be able to push something up. That just doesn't make sense. That's because everything's in motion right now. Everything's moving. Again, that pressure you feel under your feet.
Thus, we're accelerating.
Well, we're at a
How can we accelerate? We're at a constant acceleration.
We're in a constant motion right now.
Yes.
So when you release an object in free fall, it simply decelerates. So the Earth catches up to it. So it's the Earth that moves up to the object. The object doesn't move down to the Earth. But the globe Earth requires you to believe objects go down.
But if you believe that we're at a constant motion, then how could the Earth be flat?
Well, again, because
we're
the
at a
Earth,
constant motion.
Yeah, because the Earth is a level and everybody's up is the same. So we're all standing on the same orientation, moving up with the Earth. There's no orientation here on Earth is singular. It's not relative. So Earth has one orientation. It doesn't have infinite, or not infinite, but like, it's not relative.
You know, I'd probably not be the one to talk to you about this, but if you were to grab like a professor or something,
I've talked to professors.
Because I took physics 1, physics 2.
So let me just show you this. Well, let me explain to you. A cell phone has an accelerometer built in, so you're able to turn it sideways because it detects the presence of a force here on Earth. In free fall, however, if you were into free fall, you couldn't reorientate your phone because there's no force. There's no vertical force in free fall. The vertical force is only present when we're literally connected to the Earth.
If I can orientate while it's in free fall.
You need to look that up. That's why I'm out here.
Yes, you can.
So
you're telling me right now,
with the
if
air
I
bubble.
let this go, right, and I let it drop, it's just going to drop flat. Even if I tilt it a little bit, then it won't spin?
No, what I'm saying is...
Then that's a reorientation.
No. I'm talking about, like, you know how you could change it to portrait and landscape? If you were like in a parabolic flight, which is a free-falling airplane flight that simulates zero-G.
You don't even have to be in that, though. Right now, you're right here. You can let something free fall from right here.
Yeah, I get what you mean, but I'm talking about orientation regarding a force present.
That's what I'm saying, but like we don't need there's another force present.
No.
I'm saying you're talking about other contexts of which something else exists with another force that's there instead of just something plain like a simply organized experiment. If you have multiple factors affecting an experiment, then obviously you're going to have an affected result.
Right.
But if you have a simple experiment, then you won't have an affected result. So that's what I'm telling you right now. If it's just me right now dropping this like this, it will reorientate.
Okay. The accelerometer detects G-force. You know what G-force is?
Okay, but the accelerometers are also standard.
Do you know what G-force is?
Yeah.
So we experience 1 G here on Earth when we're connected to the Earth. If I download an accelerometer app and I accelerate this any direction, we're going to get a readment of 2, 3, 4 Gs because I'm accelerating. I'm increasing the G-force, right? The cell phone will detect that. Any direction, down, up, left, right, it will detect the increase in G-force. Guess what happens when I put it into free fall? It decreases. It goes from 1 G to 0 G. So literally showing that there is no force acting on it in free fall. So again, cell phones, whether digital or analog,
because it can't detect gravity.
Yeah, exactly, because gravity doesn't exist.
No, but how are you supposed to detect gravity? The only way you can
matter should be able to detect it by displacing relative to the direction of acceleration. Again,
there's accelerometers that you can use a camera and it'll detect how fast somebody's moving.
Now that's not an accelerometer. That's just a visual interpretation of it.
No, that's an accelerometer. If it's able to detect and track the speed at which someone's moving, then that's an accelerometer.
How do you know that it's the object moving down towards the Earth and it's not the Earth moving up to the object? Because we'll get the same result visually. So how do you know it's not one and it's the other?
The same way that I know.
When
I move over here, I'm moving to this area.
Yeah, because that's your life force.
It's relative to humans, and that's the reason that science exists is because it's relative to us. We wouldn't care about anything unless it was relative to us. Right. So why would we care about something that's not relative to us?
Yeah, the reason why I was doing the challenge, because obviously in 1 second, accelerating this in 2 feet without displacing, obviously is crazy. You know how fast 9.8 meters per second is? Because that's the claim of a downward acceleration. Yeah. That's 32 feet in 1 second.
Yes.
In free fall, without effects of acceleration. That's crazy.
You are accelerating.
No, we're moving.
Free fall is acceleration.
Free fall, it's a change in velocity. I agree, but it's a deceleration, and there's a change in velocity from the constant.
It's an acceleration.
No, it's a deceleration.
It's an acceleration.
It's a change in velocity.
Because over time, I'm going to be moving faster as I'm falling.
You're decelerating.
No, you're going faster. So if I'm decelerating, right? You're decelerating. Then when I hit the floor, shouldn't I be at a slower speed than when I fell?
No,
according to deceleration rules. Because if I'm decelerating, that means that I'm coming to a stop, essentially.
I'm going to explain that to you really simple. So if I have an object here
relative to the Earth, I'm coming
Right,
to a stop.
right.
But relative to myself, I'm going faster.
Okay, if I have two cars right here, well, let's say this is a car and this is a car, and I have a bar in between them, right? And this one's behind pushing this one, right? 100 miles an hour, right? And I remove the bar and this one starts to decelerate. This one's only gonna have enough time to decelerate like 10 miles an hour, so it's only gonna be like a 10-mile impact force, right? The further it's away from it, the more time it has to decelerate, the greater the impact force is gonna be.
The more time it has to.
Yeah,
But
the more time it has to
look
decelerate.
look at your perspective though. This one's accelerating,
It was at constant.
or even if that's at constant.
Yeah.
Look, you're saying this one's decel. This would be the Earth.
No, this is the Earth. The Earth is at a constant always. The Earth doesn't stop and move. It's just at a constant. It's a constant motion. That's why your weight doesn't increase. If the Earth was accelerating, your weight will increase because your body will just be will get pushed down. Because your body has inertia. Your inertia means an object at rest will remain at rest unless there's a force acting on it. So when there's no force pushing on you, guess what? Your body wants to remain at rest, motionless. So it starts to decelerate. So the more time it has to decelerate, the greater the impact of the
Okay,
Earth.
but what you're saying essentially is because we know that the Earth orbits the sun, right?
Well, that's just all belief, in my opinion. Nobody's actually been higher than 25 miles. All of that's just, you have to believe it. You want to know why people haven't been higher than 25 miles? You know how aircraft function?
Not necessarily.
So aircrafts function, helicopters, airplanes, they all function on the fact they need to push off of the air. And the air has to be at a certain density to be able to push off of it. The higher you elevate, that density of the air becomes less and less and less, and the airplanes are not able to push off of it anymore.
Look at
Yeah, they show you CGI of that.
that. There's no CGI.
I mean, so let me ask you this, because I think this is going to show... are you 100% convinced that the Earth is a ball? Or are you open to that?
100% convinced
Okay.
that it's a sphere.
That it's a sphere.
Yeah.
What's the number one proof that convinces you?
Number one proof that
Convinces
I
you?
already explained that to you earlier.
That
when I
the
talked
horizon?
about
That's
the
it?
horizontal drift. Along with that, there's other. It's been proved.
Okay, so if you could see the curvature, should you be able to physically measure it? Because
See, as compared to somebody, okay, you're able to study and you're able to come up with your rebuttals all day, right?
Right.
I don't study this specific topic enough to come up with enough rebuttals for you.
Trust me, I've heard them all.
But I'm saying if you were to get probably the best professor in here right now, he'd probably be able to debunk some of the things
No,
that you're saying.
he can't debunk physics. Physics
Not
is what it
necessarily
is.
me, but someone in there.
No. Well, real quick, because I know you're stuck with the curvature. So the NASA claims to have satellites orbiting the Earth, which they claim...
Earth's curved. Why is this a circle?
Okay, and the
That
rate...
goes against your own. It's a.
No, this is the numbers they give us. So they're telling us the radius of
But
the
why?
Earth. Let me explain. You're jumping ahead. So the globe Earth, they claim to have satellites orbiting the Earth, right? So they need to know the radius of orbit if they're supposedly going around it. So they need to tell us the radius of the Earth.
Why is nobody falling off the Earth yet then?
I'll get to that one next. So the radius of the Earth is 3,959 miles, and based on that radius, we can calculate using a simple calculation, a squared plus b squared equals c squared, the Pythagorean theorem. We can calculate for this curvature. So again, in 5 miles, there should be 16 feet of curvature. But if we actually went to a giant lake that was miles across to physically measure for this curvature, we understand the physics of water. Again, water, when contained at rest, will always form a level surface, which is horizontal.
Not necessarily.
But they're trying to tell us that the
Not
surface...
necessarily. Water takes place of the container of which it's
Yeah, it takes the
in.
shape,
Takes the
but
shape
the
of whatever
surface
it lies
always...
on.
But the surface is always level. Pay attention
So
again.
no. What about waterfalls?
Yeah, that water is moving. I'm talking about contained and at rest.
No. If it's at rest and if you chop off a piece of it, right?
Yeah,
Will it not fall down?
Yeah.
And move over?
yeah. The water's being
Okay, then that
contained.
explains to you right then and there that there is some sort of curvature along the Earth, because if there's a chop off, right? Say you have a piece of
Okay,
you have a block
okay,
and your
let's-
water's moving over the
Right,
block, right?
right.
You chop the block.
I'm not talking about moving water. I'm talking about...
Okay, water's stagnant right there, right? You chop the block. Water's gonna start to move downward.
Okay, without chopping the thing, do you think the water can bend without chopping the
But
thing?
that's the thing about the Earth. The Earth is a bunch of chopped rocks. It's a bunch of rocks that have been
Okay.
molded, moved around.
Have you ever
know
been to
what
a
I'm
lake?
saying?
You've been
Yes,
to a lake,
I've been
right?
to lakes plenty of times.
Okay, so if we went to a lake that was miles across, like
Then
3
don't
miles
look at
across...
lakes, look at oceans. Because why would you look at a lake?
Have you
Lakes
heard of the term sea level?
Yes.
What's your definition of level?
Level? It's also relative.
So what's
Sea
level?
is also relative.
So you think level means Earth?
Not necessarily. It means where the water touches the land.
But what will be your definition, like a practical definition
the height
for
of which
level?
the water touches the land.
Because I have 2 definitions for level. One is level means horizontal, which is perpendicular to the vertical. And the second definition for level, in my opinion, is no deviation in elevation from any point, any starting point and any other point. So no deviation in elevation. The globe Earth claims deviation in elevation. and it increases more and more and more. So in 3 miles, there should be a 6-foot drop. Again, if you start at 5 feet, that drop should increase to 11 feet. But in 10 miles, there should be 66
There are
feet.
differences in elevation, and you can even see
Yeah,
that
they
here
are.
on-
They are. You know how we measure those differences? From water level. Because water is the number one tool to measure horizontal. So any depths or heights are done
Look,
from the
can you
level.
get to why nobody's following up the Earth yet?
Yeah, because it's being contained. So we have air pressure here, right? 14.7 psi, the air. So in order for air to be able to maintain pressure, it needs to be physically
So then
contained.
somebody has bounced off the side and then came back.
Well, not balanced, but I'm sure maybe the government has reached the
But
container
that's the
walls.
thing, though. It's not the government. Other people have traveled and
There-
explored. and
you need to
seen
look up
this.
the Antarctic Treaty. Independent explorers are not allowed. So if you were a millionaire, you cannot independently explore this place. There's a lot of restrictions, military restrictions that would not allow
Sorry,
you to.
but
No, trust me. You
from
could.
what I remember is that prior to the government existing,
Right.
our government,
Sure,
essentially,
sure.
you know, there was other
Do you
governments,
think
other
history can be
worlds.
altered?
I don't think history can essentially be altered.
Yeah.
no.
So how would you, if you believe that people have done it in the past, and you know history can be altered, how can you take those as fact?
How can I take that as fact?
Yeah, that people have explored this
The
place.
same way that I can tell you, hey, I just took a step right here.
Yeah, that's you doing
I
it.
just
though.
took a step.
I can't prove that people 100 years ago did something. I just have to believe it.
But there's documents. Yeah, exactly. You have to.
How do we
believe
know
it
those documents are being doctored or made up?
Because you can test them.
How do you test them?
You go and you sail around the earth.
Oh, I'm talking about.
That's how you.
Yeah, nobody's actually done that. Physically, the full dimensions of the Earth is unknown. I know that's a hard pill to swallow, but the full dimensions of the Earth have not been explored. So we don't know how big the Earth is
Obviously,
or how small it
there's
is.
estimates of it though.
Yeah, we have Google Maps. That's a projection. That's not reality.
Not
though.
Google Maps. Other people more sophisticated than Google Maps.
I mean, what's more sophisticated than Google Maps?
What's more sophisticated
Yeah.
than Google Maps?
Yeah.
Google just uses satellite projections. I'm
So what's
talking
more
about the people
sophisticated?
The people that actually get the satellite. Well, then if you believe in Google Maps, then you should believe that the Earth is.
No, what
round.
I'm saying is that they have an idea that they show us, but that's just a projection. That's what they want us to believe. At the end of the day, reality is not a projection. So what they show us in the map.
What good would they get out of lying to us?
Oh, I'm glad you got there. So, well, I mean, you're 100% convinced that they're not, but I'll tell you why still. Okay, first of all, I'm not the one lying, so ultimately I don't know, but I'll tell you my reason. I think it's about control. So it's not about the shape of the Earth. It's if they could get you to believe something that's not true, that means you've been mentally handicapped. So you're going to be more easily controllable now. Because you rather take authority over your own common sense. You rather believe
Would
authority.
a flat Earth do that better?
No. The flat Earth is bullshit too. Over 95% of flat Earthers believe in downward
Then
acceleration.
what do you believe in?
I don't believe anything. I go with what reality shows me, that the force is us.
So then, if you don't believe in anything, then what's your argument? What's the end?
Well, I'm presenting facts. I'm not presenting beliefs here.
That's
This is
the
what I
thing, if you're
know.
presenting
It's either I know something or I don't. I don't have beliefs about objective reality.
But your facts can lead toward a belief.
No, because I agree. The fact is that the Earth is pushing up. People have this question. Well, what's pushing
But
up
we're
the
also
Earth?
pushing down.
Well, that's inertia. Your body's resistance to motion.
That's gravity.
No, gravity claims that there's a flow, a gravitational flow.
It's the act of gravity along with your mass. So you're also right. It's also inertia. But guess what? It's also gravity as well. There's different forces. There's different vectors of force hitting you at the same time. It's not all the same.
Two vectors moving in opposite directions. I mean, a vector moving in opposite directions at the same time.
Yes.
That defies physics.
Multiple.
Yeah. So if you have
that's when you get a sum vector that causes you to go in a certain direction.
So when you have
a certain direction is just straight stagnant.
no, well, it's stagnant because of inertia. It wants to remain motionless.
I'm telling you, it's because of you have different vectors of force hitting you at different angles. And
It's
for
only
that
one
reason,
force, and in inertia is the resistance to that
there's
force.
multiple forces.
Well, I would say that's just a
Is
belief.
the wind not a force?
So you
Is the wind not a force?
yeah. When we're
So
talking
then
about
that's another force other than inertia.
Sure.
So then that debunks what you just said, that it's just one force.
when we're talking about the vertical force we experience here on Earth, though, is it up or down? That's the question. You're saying it's both. That doesn't make sense.
I'm saying that it's down. When you physically
So how does the air-
experience
how does the-
gravity, it's downwards,
Okay, if it's-
right? However, the Earth pushes back up on you. And
How does
for
the
that
Earth-
reason, that's why you're
Let me ask you this.
Because it's an equal and opposite force, therefore,
How does the
if there's
Earth-
equal and opposite force, then you won't move.
How does the Earth push up without moving up?
You're pushing down on it.
So how does the Earth pushing up? So it's just
You're
resisting.
pushing- It's equal
So-
and opposite force. That's what I'm
So the
telling
Earth
you.
is
It's
just
a
there.
resistant force.
Okay, so if the Earth is just
It's
there,
a normal resistant force.
so if the Earth is just there, right, resisting the downward force. first of all, there is no downwards force that could be measured. So I don't know if you knew Einstein's theory of relativity. Have you heard of that?
And that's where I tell you, there's also orbit around the sun, and for that reason, there's also another force of gravity that we're concurrently experiencing as well.
So
you're not just experiencing one force of gravity from the Earth, but you're also experiencing another force of gravity from the sun, which you can't feel. But the Earth feels it.
Right. So you heard of Einstein's theory of relativity, right? The bending and warping of space-time. So in his theory, again, it's not fact; it's a theory. He acknowledges that gravity is not a force, and he has to acknowledge that because, again, accelerometers clearly debunk that claim.
So what makes you believe in Einstein then? If you can't,
I don't believe him. He's just admitting that the fact.
Okay, but why are you quoting Einstein if you said if you can't?
Because you keep claiming that there is a force in free fall, but even your globe Earth priest claim that there's not. Yeah, Einstein is a globe Earth priest, just like Neil deGrasse Tyson, just like all of these mainstream scientists. They all claim gravity is not a force.
You can't quote somebody for one thing and then quote them for another.
No, I'm quoting them because they acknowledge the facts that I'm presenting, but they twist it. They acknowledge that fact, but then they say gravity is not a force, but it is. But it still accelerates up. Yeah.
Right. If somebody's to study something their entire life, that's because they've seen it multiple times over and over.
Exactly. It's just like displacement when you accelerate. Exactly.
You know how old Einstein was when he died?
That's irrelevant.
Right?
But
It doesn't really matter, right?
No, it doesn't matter.
But was he relatively old? We didn't study that for his entire.
Could he have been bought out?
Yes.
So how do you know he wasn't?
I don't think he was bought out.
Okay. Well, then that's just your belief.
Because why would somebody study something that fucking boring for their entire life?
Makes money. That's why.
It makes money.
Yeah. So basically, gravity.
If you're growing interest in something, you actually have to genuinely love it.
So this is the explanation for gravity. They claim it's not a force, but it acts like a force. That kind of force cannot be replicated. Though. That kind of force claims that you can accelerate this without that displacement. That defies physics. Can you imagine a gravity machine being able to do that? It won't happen. Here, take my channel. You can check your stuff out later on if you want. You want to look at yourself later?
Hey, the guy,
All right, no worries, man. Take care.
Could I call you back after it? I'm gonna keep you updated. But okay, all right. I will. Love you, and thank you, Mrs. Colombo. That is so nice. Thank you. Bye, guys. Love you. All right, man. I heard you talking about vectors, and I'm a little concerned.
Yeah.
I don't know about that, but I'll do it.
No. It's very easy.
Okay.
So $100 challenge. See if you can do it. So what I have here is a container with water and a buoyant ball in there, a plastic ball.
Okay.
Right. So when I accelerate this, regardless of the orientation, when it's at rest, when I accelerate it, the ball always reacts, right? It always gets pushed in the direction I accelerate, if you pay attention.
Yeah.
The initial acceleration, the ball always gets pushed in that same direction.
Yeah.
You see that, right?
Yeah.
Now the challenge is, can you accelerate this container to this line in 1 second without that displacement?
So without the ball moving?
Without the ball moving, yes.
Can I accelerate?
Yes, do it. You can try as many times as you want. From here to here in 1 second.
Okay.
Okay, that's more than a second already.
Oh, I get it.
Yeah.
So I basically have to slingshot it and twist.
I mean, even if you use the slingshot, it's still gonna displace. Even if you use air to push it.
Okay. Wait. Can I move it here to here without any displacement?
Yeah.
Displacement is like
the ball being pushed. So
without
the ball
relative,
moving. Yeah.
relative to the container.
Yes,
okay, I was like, that's inherently just okay. 1 second.
1 second. That's only a distance of 2 feet, less than 2 feet, because this is a 4-foot table. So less than 2 feet in 1 second. You think it's possible to accelerate it without the ball moving or reacting? Because the ball is always going to react, right?
I'm going to assume it is possible since this is a $100 challenge, but I'm thinking about how to approach this. Yeah. I noticed it if I spin it. I'm just being purely empirical right now.
But I mean, even the bubble's moving though.
Oh, that counts?
Yeah, that counts.
Okay. But if I'm like very precise, then it doesn't move, right?
But again, in 1 second still.
Yeah.
So here's the fact: it's impossible. So it's kind of like a trick challenge in a way.
Okay.
So the reason why I'm doing this is because again, it will always react to acceleration, right? And even if I accelerate down, it will also get pushed in the direction of acceleration down. So let me show you this real quick. I had two. So before I show you this, when I'm holding this at rest, it's at rest, and I release it, do you believe gravity accelerated down to the earth from being at rest? Yeah. So I actually did two tests here. one I actually accelerated down, and one I didn't. Which one would you say I actually accelerated down? The one on the left or the one on the right? Which one did I actually accelerate down?
Right.
Exactly, right? Because we see the effects of acceleration, the push of the buoyant ball. So in free fall, there are no effects of acceleration because there is no acceleration in free fall. So I don't know if you knew gravity is just a theory. So that means that they never actually measured a physical force in free fall. And the reason why is because matter doesn't react to a force in free fall because there is no force in
Are
free
you
fall.
disputing the validity of gravity?
Yes. So the
That's a little crazy for me.
So gravity's not a pull, it's a push. That's basically what it comes down to. Gravity is real, but it's not a pull. It's not pulling you down towards the earth. It's the earth pushing up against you. Buoyancy proves that because if I was to cut the string of this ball, what direction will that ball move?
I'm not qualified to talk about this, but I'm going to trust scientific consensus.
Okay, I would say that's just an appeal to authority, but
No, it's an appeal to quite literally centuries of authority and people who are far more
Exactly.
educated than both yourself and myself. And it's proven with empirical data and theoretical.
well, simple accelerometer like this debunks like downwards acceleration. That's why gravity's a theory.
I'm sure if I asked, a physics professor right now and
Yeah.
said, hey, could you come over here and dispute this
Oh,
guy?
I would love that.
I'm a history major, so I'm not qualified
Yeah.
to say, this, you're wrong, here's why.
Yeah, I would love to have a conversation with a professor, by the way. They all run away, but yeah. I actually have
Okay.
a YouTube channel, and I do open panel live streams all the time for anybody that wants to come on and talk to me about it. And I also
I'm
do
all
these street
right.
interviews.
I think gravity is real, bro.
No, it is real. It is not a pull, though. It's a push.
Okay.
All right, take care, man. Oh my god. Oh fuck. Oh my god, man. This is gold, man. This is gold. Oh my god. Oh my god. What the fuck is going on, man? Oh, what the fuck? Oh my god. I can't fucking believe it, man. That's crazy. Oh man. Wow. Wow. I've never seen so much pushback. Damn. And not even that. Like, I've never seen so much nonsense in a span of 30 seconds or a minute. Like, what the fuck? The last two conversations. What the fuck? What the fuck? It's like they're grasping for straws. Like, it's fucking tripping me out, man. It's crazy. It's like kind of unplugging someone from the Matrix, right? And then they just plug themselves back in. Like, okay, I'm good. That's literally kind of like the reactions I'm getting. Literally. People are getting unplugged from the Matrix and seeing the reality, and then they just plug themselves back in because it's just too real. Like, no, you're wrong. You're like, what? That's fucking crazy. Fucking nuts. Fucking nuts. You guys want to try the challenge?
Yeah.
All right, so very easy. Very easy challenge. So here I have this is what I would call a simple accelerometer. And the reason why it's an accelerometer is because obviously I have water inside this container and there's a buoyant object in there, right? So regardless of what direction I accelerate this from being at rest, the ball will always get pushed in that same direction, right? Like, regardless of the acceleration, the ball will always get pushed in that direction. The ball will always react to acceleration, basically. So the challenge is, can you guys accelerate this container from here to this line in 1 second without the reaction of the ball? If you guys can do that, then you guys win $100.
Without reaction.
So you guys have to accelerate this, yes, to this line without the ball reacting to the acceleration.
I can move this in any direction, or like.
Well, ultimately, it has to stay at rest, and then in 1 second, bring it from this position, accelerate it to the line without the ball reacting, without it being pushed.
But I move it horizontally.
I mean, it has to be like that because that's the way I have it laying. And you're still reacting.
Okay, man.
Can you do it vertically?
好烧脑哦，这样的。
No, it has to be done vertically. That's the
Okay.
challenge. That's the challenge.
I can't move it. Like, it just.
You're just always going to react, right?
Yeah.
Yeah, so that's the fact. The fact is that's impossible.
No.
That kind of acceleration without any reaction
Yeah.
defies physics.
Yeah, it's definitely like something you need to think out of the box, but I can't think it right now.
It's impossible. You couldn't do it. I
So
couldn't do
why
it
is
either.
it like a
Oh, really?
$100
Yeah,
challenge?
it's impossible. So no matter what direction I accelerate, and the faster I accelerate, the more it's gonna react, right? Even when I accelerate down, the ball gets pushed down in the direction of acceleration. So let me just show you guys this before you go. I have two water bottles here, but I only accelerated one down. Again, the red ball is a ping pong ball that's buoyant, and then the steel ball is obviously dense. But which one of these two did I actually accelerate down? Based on how the buoyant effect, based on the buoyant effect. So I accelerated one of these down. So which one shows reaction?
That one.
The one on the right,
red one,
exactly. Yeah, that shows a reaction to acceleration. The one on the left is actually free fall, which shows no reaction to acceleration. That's because there's no force in free
I
fall.
see, I see.
Did you guys know that gravity is just a theory?
Yeah, I know.
So gravity, again, the pulling force of gravity has never been actually been proven or measured, in other words, because matter doesn't react to acceleration in free fall, because objects don't accelerate down. The fact is, the Earth doesn't pull you down towards it, it's literally pushing up against it. And buoyancy proves that, because buoyancy, it's an effect of the container that's moving. The buoyant effect will always move in the direction that the container's moving, right? If I was to cut the string right now, what direction is buoyancy?
Yeah.
So the Earth is literally pushing up
I
right
see,
now.
I see.
So this is the main reason I'm doing this. Do you guys believe the Earth is a ball? So if up is relative on a ball, it's like if you're standing here, up is that way. If you're standing here, up is this way. It's relative, right? In all directions, up. And we could prove that the Earth is literally pushing up or moving up. If we could prove that, how would that work from a globe if the Earth is moving up?
You should go down. You should go up.
So if you're standing here and you move up, well then how will the people down here, how would that work
Go
for
down.
them? So it goes up like this and then like this?
Yeah.
Well, that wouldn't work. It has to be simultaneously. How will the Earth move up simultaneously on a ball? It wouldn't work. It would mean we'll have to be growing. It would literally explode. It wouldn't work. So the fact is, gravity is a theory to make people believe that the Earth is a ball. Because without that belief that objects accelerate down towards the Earth, then the globe Earth wouldn't work.
Oh, that's so
why,
interesting.
yeah, that's why gravity is just a theory. So I don't know if you guys heard of flat Earth, right? So this is where flat Earth is a psyop, and in all mainstream flat Earth channels, and over 95% of flat Earthers believe the Earth is motionless. So what does that mean? They actually believe objects accelerate down as well. So then the flat Earthers claiming that are keeping the idea of objects accelerating down in free fall, which is keeping the whole idea of gravity alive, which is keeping the whole globe Earth idea alive. So it's a false dichotomy, the motionless flat Earth versus globe Earth. The fact is the Earth is level because it's literally pushing up against it. That's the fact. So gravity is not a pull, it's a push. And again, buoyancy shows us that. Because again, matter cannot move on its own. Why? That ball cannot move itself up. It requires a water pressure, but the water can't have pressure unless there's a push. That's what pressure is, it's a push. So right now the table is pushing up, the Earth is pushing up the table is pushing up the bottle's pushing up the water, that's creating the pressure gradient, which is pushing up the buoyant object. As soon as we put this into free fall, that pressure within the water vanishes.
I see.
Because it requires
That's
a
pretty
pull.
interesting.
So this is the number one proof that debunks the globe, the fact that there is no physical downwards acceleration in free fall. It's literally the Earth moving up to the object.
What do you believe in?
So I don't have beliefs, I just go with what reality shows me, and reality shows me that the Earth is in constant motion upwards. So the Earth, again, we're all standing on the Earth, and everybody's up is the same. So orientation here on Earth is singular, it's not relative like they tell us on the ball. So again, the reality is the Earth is a level extended plane, and nobody knows how far it extends.
Yeah, it's
that's a mystery. But I kind of tend to go with the fact that when you have air pressure, like in a tire in your car, to maintain that air pressure at a constant, you need a solid container. Because if there's a tiny hole in that container, guess what happens? The air starts to rush out.
Yeah.
So the Earth, we have 14.7 psi here of air pressure that's being maintained. What does that tell me? That the Earth is being physically contained somehow. So I know you've heard of people talking about domes. The Earth is covered in. I don't know exactly what the container looks like, but it's definitely being contained. So people talk about, oh, how do you will fall off the edge. It's like, no, you won't, because it's being contained. Nobody's been to the edge or the end. I would call it the end of the earth, which will be the wall of the container, you know.
Oh, wow.
So let me ask you guys this: are you guys 100% convinced the earth is a ball, or are you guys open to the idea that maybe we have been lied to?
I think I'm open to any ideas.
Oh yeah, definitely, especially if there's physics to back it up, you know, practical demonstrations.
Yeah.
So let me ask you guys this: what's the number one proof that convinces you that the earth is a ball? Respectfully, if I may ask.
Maybe photographs from the astronaut.
Yeah. So NASA, let me just show you these. I have a couple. So these are official NASA images, and I call them images because they even admit they're images, they're not photographs. So they admit that they have satellites orbiting the Earth, and they take strips of imagery and they make these in a computer. So these are all Photoshop. So a genuine photograph of the Earth from space doesn't exist. Even NASA admits, you know. And even if they didn't admit that and they claim that these were real photographs, well, guess what? These photographs still defy physics. That wouldn't work. So if I showed you a picture of me flying, you wouldn't believe I could fly, right? Because that defies physics. Right? Just real quick before you guys go, the number 2 proof, again, based on the dimensions of the Earth, they tell us the radius of the Earth is 3,959 miles. And using a simple calculation or a Pythagorean theorem, a squared plus b squared equals c squared, we can calculate for this curvature drop every mile. So they're trying to tell us that the Earth is curving 8 inches per mile squared. So if we went out to a giant lake that had water in it and it was contained and at rest, they're trying to tell us that the water's bending 6 feet in 3 miles and increasing more and more and more. But the fact is that any lake on Earth you go, the water is always going to be level, which means horizontal. And a physical measurement of that will show that. Again, they're trying to tell us that water level means this, but water level actually means horizontal. So this will be the number 2 proof to debunk the globe, is the fact that there is no measurable curvature here on Earth. You know, that's why the oceans are called sea level, because level means horizontal. Exactly. So the continents are not around a globe, they're just across the way. You know, it's an extended plane with continents, like a giant pond, pretty much. That's what the Earth actually is. But I mean, do you guys have any questions for me about this subject? I know I'm...
Oh yeah, why are you doing this? Are you from USC?
Yeah, so no, I'm not from USC. I'm here to challenge the students. I go to UCR as well. I've gone to UC Irvine. So what I'm doing is challenging the current narrative, because online is super censored, this topic. And again, with mainstream flat Earth as well. They have a false dichotomy, motionless flat Earth versus globe Earth, which both believe in a downwards acceleration, which doesn't exist. The fact is literally the Earth pushing up against you right now. And I'm out here talking to people because, again, this is the number 1 censored topic on Earth, because it's the easiest to prove. And that's why it's the number 1 censored. And then they have a lot of controlled opposition. That's the fake flat Earthers. The fact is the Earth is not flat, it's level. Because the level is an orientation, and orientation requires motion. So again, the Earth has motion. So that's the fact. So gravity is a push of the Earth, not a pull. So it's literally that simple. So let me ask you guys this: if what I'm saying is true, which obviously I'm not going to expect you guys to accept it right away, but if what I'm saying is true, would this be something important to talk about?
Yeah,
like if you
children are educated to okay, Earth is a sphere, and Earth is not the center of the universe. They're educated this since they're in maybe primary school, so it's a common knowledge.
Well, that's what they're trying to make it seem. They don't really teach us the globe. They just tell us the globe. If you really pay attention, they don't really teach us the circumference of the Earth, for example. They never tell us the circumference of the Earth. I had to find this out myself, because again, once you find out the circumference of the Earth, then you can find the radius. When you find the radius, then you can find the curvature. And the fact is that curvature doesn't exist, and that's why they don't highlight that curvature. You know, because it's ridiculous. If you go to a lake and when the water's calm and at rest, that surface of the lake will never concave. You know, water doesn't have that physical ability to do that. Water will always collapse and form an equal surface, which is level, which is horizontal. So again, it doesn't matter, what the size. I can make this container 1,000 times bigger. The water inside will always display level when it's at rest. You know, to claim that it could have a hump that's increasing more and more and more, that defies physics. And that's why I say these images defy physics, because they're depicting water curving around a ball at 8 inches per mile squared, which doesn't exist.
Yeah, I think your thoughts are pretty interesting, but I think it still needs maybe more official scientific movement. But I think your thoughts is so interesting.
Buoyancy, keep that in mind. Buoyancy, it's an effect of a container that's in motion. So the Earth is the container, and when you release a helium balloon here on Earth, that's a buoyant object. At what direction does it go? goes up because that's the direction of the vector. So we do have a vertical vector, except that the globe Earth claims is down. The fact is that vector is up. It's literally that simple to debunk, and that's why it's the #1 censored topic. Do you guys have any other questions? I mean, before you guys go, I mean.
Actually, we two are not major in physics, so we're like
Well,
our knowledge base for this is kind of shallow. So.
Believe it or not, though, this is kind of elementary physics. It's like a 10-year-old can grasp this. A 10-year-old can grasp that this will always move in the direction of acceleration, which doesn't happen in free fall.
It's impossible.
Proving that there is no downward acceleration. Yeah, he had a conversation with me first already. So I mean, if you guys don't have any other questions, here I can give you my channel. You guys can check it out. You know, I have conversations like this all the time. I definitely, you guys can take this. I have plenty.
Yeah. All right.
Yeah.
Thank you.
All right. Thank you. Thanks for the chat.
Are you going to use this anymore?
Yeah, you guys can check it out if you want.
Oh, can you like not put us up there?
Oh, sure. I can blur your face
Yeah,
if you want.
great,
Yeah, no
thanks.
worries. You want to take one too? Or-
Oh no, I'm good.
Okay. All right. Take. All right. From now on, I'm gonna ask if they're okay with being on camera. If not, they're just gonna have to keep walking, because if you're gonna have an open conversation in public with cameras literally in your face, and then you're gonna, at the end of the conversation, you're gonna ask to not be on camera, even though you basically consented by coming up to the table. You know, I don't think that's fair. You know, it's fine though. Again, I would rather just have a conversation with someone that is open and is not shy to show face at the end of the day. So from now on, I am gonna. I might just blur her face, since the other girl was cool, I guess she mentioned that, but I'll just blur her face this time. But I'm gonna try to make it a point to let them know that you're being recorded and you're okay with that, right? Before we even start, because I feel like the topic of conversation is what turns people off to wanting to be on camera. So that's gonna be my main thing in the day. I'm gonna need to highlight that because, yeah. Like, it sucks, man. Like, imagine not being able to see people's reactions. Like, that kind of takes from the whole point of me, you know, highlighting and having this conversation in public, you know? I think how people react, their face expression shows a lot. It could show even more than what your words are saying, right? Because you could be saying one thing, but your expression clearly shows something else. Like, it could be mind fucked, right? You could be zoned out. You could be angry. And you could show all these expressions just by looking at someone's face. You know, you don't even need to, again, so blurring someone's face when it comes to having these conversations, to me, kind of defeats the purpose in a way, you know, but to each their own, I guess, right? Oh, gotta have the sign up. Yeah, I need that Velcro thing. Yeah, I'm gonna make it a point too, because people are flipping. The way people are accelerating this is because I tell them without the bubble being moved, they start to spin it and move it. But that's why I have to say in 1 second, 2 feet in 1 second, right? Because if they start doing that slowly, not only is it not accelerating, but it's also not in 1 second either. And I've seen people turn it on its side right now. They turned it on its side. They even turned it upside down, you know, which obviously if you turn it upside down, probably do if the ball's already being pushed to the front. If the ball's already being pushed to the front and you do that, then you're not going to get any displacement because it's already being pushed to the front, right? So again, it has to be in this orientation. That's why I need to highlight in this orientation in 1 second, a distance of 2 feet in 1 second. I mean, that should be easy, right? To accelerate that in 1 second over a distance of 2 feet without displacement, right? That should be cinch. It should be easy, right? Especially since gravity claims 32 feet per second without displacement, which is 16 times faster. 16 times faster than the 2 feet per second acceleration. I mean, if they could do that without displacement, we should easily be able to do 2 feet in 1 second. 16 times slower. We should be able to get that acceleration without displacement, but guess what? It's not there. You know, because it doesn't exist. It's literally that simple, you know. So again, it's only a matter of time before this actually takes off, I guess you could say, right? I like to think I'm even though I've been in this topic about the buoyancy and the Earth push and for over 2 years now, maybe a little bit over 2 years. Obviously, the flat Earth. I've been in the flat Earth conversation for over 8 years now. But this accelerometer one, I've only been at it for about a little over 2 years, if anything. And, you know, and I didn't grasp it right away. Like I didn't get it right away. Like boom, you know. It took time. It took time for me to actually think about it. Think about the effects. Literally, that's what did it for me. I was thinking about the effects of accelerating.
Hi, what is this?
So I want to see if you guys can do a challenge. I'm actually showing you. So it has to do with this. So here I have a simple accelerometer, and the reason why it's a simple accelerometer is because this device detects acceleration.
Yeah.
So I have water, and there's a buoyant ball in there, a red plastic ball, right? Yeah. Regardless of the direction I accelerate, that buoyant object will get pushed in that same direction from being at rest. If I accelerate this way, the ball will get pushed this way. If I accelerate that way, the ball will get pushed that way, right? And in any vector, it doesn't matter, right? The ball reacts to acceleration 100% of the time. So the challenge is, can you accelerate this, how it is, vertically, from being at rest to this line in 1 second without the reaction of the ball? Do you think that's possible?
And you can only move that.
Yeah, you have to accelerate this container to this line in 1 second without the ball moving.
It has to be still vertical?
Yeah, it has to be vertical.
Wow, that's upside down?
It has to be like in this orientation.
No extra gadgets or anything?
I mean, you could use anything you want, any force to accelerate this.
So the whole rule is we're only allowed to apply forces to it?
Yeah.
Okay.
In 1 second.
In 1 second to here. So a distance of 2 feet in 1 second.
Okay. Wait, let me just figure out the
Yeah, so just
So even at slight, it'll move.
Yeah.
Well, the reason it's moving forward is because the water's
Pushing back.
more dense than
Yes.
in the ball itself.
Yeah, you
so
get
it's-
it. Yeah.
Engineer over here.
Oh, that's good. That's good. Do you think it's impossible?
I don't know about impossible, but I mean,
I don't think it's impossible. I think
technically. Okay. And we,
In 1 second.
in 1 second, and you're not allowed to, and you don't want it displacing in any direction, right?
I mean, yeah, basically. But
Okay.
I mean, if you accelerate it front, it's always gonna go to the front. Like you can
Yeah.
accelerate this and then it goes to the back. That's another impossibility in my opinion.
Yeah.
So the fact is, it is impossible.
it is.
Yes, it's impossible. So it's like me asking you to fly, or
Oh.
me asking you to walk on water.
Right.
You can't break physics.
Yeah.
So this will always react to a force. It will always react to acceleration. That's the point. So the reason I'm doing this is when I have this at rest right now, right, and I release it, do you guys believe gravity accelerated down towards the earth? Yeah. So here I did it in slow motion. I accelerated one down, and can you guys tell which one I actually accelerated down? The one on the left or the one on the right? Which one did I actually accelerate down? The matter within the container is going to show you which one's accelerated
Right.
down. Because the more dense goes towards the back, and the less.
so that one.
Yeah, exactly. That's the one I actually accelerated. Because as soon as I apply a force,
Yeah.
the reorientation of matter happens. The more dense goes toward the top, and the less dense goes towards the bottom.
Yeah.
The one on the left here is free fall, which people claim is acceleration, but the fact is gravity is just a theory, and the reason why it's a theory is because a physical downwards acceleration has never been measured. So accelerometers don't detect acceleration in free fall.
It is accelerating. It's just that the water is accelerating at the same rate in free fall.
So that's what I was saying. That kind of acceleration that can accelerate without displacement doesn't exist. People that claim that happens in free fall, I would say that's special pleading. So that's why gravity is just a theory, because it can only be demonstrated in free fall, which is the observed phenomenon. The fact is the earth is not pulling you towards the ground, it's the earth pushing up against you. So gravity is not a pull, it's a push. And buoyancy shows us that, because like you said, buoyancy will always get pushed in the direction of acceleration. Again, I can demonstrate that here. If I was to cut the string, what direction would the ball move?
It would still move the same way.
No, if I cut the string right now, what direction would the ball move?
Stop this buoyancy.
Exactly. Buoyancy, again, what is buoyancy, if I may ask?
So this ball is displacing a certain amount of volume in the water. The water is more dense than the ball.
Yeah, like you said right now. Yeah.
And so the ball gets pushed up by that force.
So again, yeah, so the water is pushing up the ping pong ball.
Yeah, so
I mean,
buoyancy is just gravity of the water pulling down.
But gravity is a push. That's my point. So right now the Earth is pushing up the
by
table,
that.
the table's pushing up the bottle's pushing up the water, and the water's pushing up
That's
the
the
bottle.
normal force that just opposes the gravity.
You're talking about normal force.
Yeah.
They talk about the normal force because they have to, because buoyancy shows that there is an upwards force. But the fact is, this downwards force that they claim goes against buoyancy doesn't exist. Because if that force did exist in free fall, a vertical downwards acceleration, buoyant objects wouldn't go up. They'll go down too.
Is there like a reading?
But the only reason buoyancy exists is because there's a normal force that keeps the water like pressed up. So like, if the water in this example stayed, in the free fall example, stayed still, if it had a force like pushing it, like maintaining it,
Right.
then it would still act the exact same way as that. The only reason it's in free fall is because all of those things together are moving.
Are accelerating together, right?
Yeah.
That kind of force doesn't exist. That's my point. That kind of force cannot be recreated nor demonstrated in any other vector, and that's why it's just a theory, and that's why it's just special pleading. For special circumstances that's happening in free fall.
Is there like a
So,
reading?
like if I
Yeah, I actually do have something I can share with you guys.
if I drop this, like what's that?
That's a deceleration from the constant.
No. Like when pretend I don't.
Yeah, right now everything's in motion
When
already.
it's in free fall, it's constantly
It's
accelerating.
decelerating. It's changing its rate and velocity. Yes, it's changing the rate and velocity, but it's decelerating. It's losing momentum. That's what's happening. The Earth is moving up to it. That's not moving down towards the Earth.
I don't buy that.
No, that's what physics shows. That's what physics shows. That's my point. That's why I'm out here. So let me ask you guys this. So everybody's cell phone has an accelerometer in it. That's why you could turn a landscape and portrait. It can detect the vertical force, right?
Yes, that's correct.
And you could download an acceleration app on your phone as well. And what that does is goes, because on Earth we have 1G, right? When you accelerate that accelerometer on your phone, it registers 2, 3, 4G. Depending on how much force you apply, it registers plus G. Down, it doesn't matter what direction you accelerate. In free fall, however, it goes from 1G to 0. So it's a deceleration. Even cell phones show that. So a digital accelerometer or an analog accelerometer shows that there is no downward acceleration in free fall. And again, this is the biggest lie on Earth, and I want to tell you guys why. Do you guys believe the Earth is a ball? What?
Yeah.
So,
That's true.
if up is relative on a ball, right? If you're standing here, up is this. If you're standing here, up is this. In other words, it's in every direction away from the center, up. And if we could prove that it's literally the ground moving up, pushing up against you and not pulling objects down, how can the Earth be moving up if it was a ball?
You're making an assumption that it moves up. But if
No,
it doesn't-
hypothetically, if the Earth was moving up,
Well, then yeah, that
it wouldn't work, right?
This proves that the Earth moves up.
No. So if we obviously you understand that the Earth moving up wouldn't work from a globe Earth model, which is why it's the number one lie on Earth that objects accelerate down in free fall, because that idea is what's keeping this whole globe Earth idea
Well,
alive.
what if we just say it doesn't accelerate down, it accelerates towards the center of mass of the Earth,
I mean, it's still an acceleration, and matter should react to that acceleration.
and matter should react to that acceleration?
Yes.
Oh, you're saying like why why this doesn't detect free fall?
In cell phones too, accelerometers, any accelerometer.
Yeah, I can explain that. So when
Why?
it's just at a standstill, like everything is, even when you're standing still, like this is still experiencing a gravitational force, correct?
Well, I would say
Even if it's not moving,
experiencing an upwards force. That's why the ball's moving up.
a force doesn't necessarily mean that it's going to be moving.
Well, if I cut the string, the ball will move. Its push is pushing up right now.
Sure, but like pretend even like this water ball, like forget the ball, like if it's just standing still, there is a force on it.
Yes, I
applied.
agree. It's up though, but yeah.
There's one down and there's one up, and they balance each other perfectly, so that's why it's not moving. And then when it goes into free fall, that gravity force still remains, and that's why it's moving downwards. Like,
So you think it goes from rest to acceleration?
yeah, and maybe the phone accelerometer doesn't read that because it's calibrated for when it's at rest.
So the way accelerometers work inside your cell phone is there's a device in there that has rigid parts, and then it has some other parts that are loose. So it's like teeth that are coming together like this. So when you accelerate the phone, or those loose arms, they displace, they move relative to the direction of the acceleration, right?
Yeah.
So there's displacement inside your cell phone as well. So again, in free fall, we don't have that displacement because there's no force acting on it. Now you're saying that the change in velocity that you experience in free fall, again, that can simply put this way, if the Earth was moving up right now at a constant motion, everything was being pushed up. And then obviously because my hand is pushing it up, it's underneath it, right? As soon as I remove that, this no longer has that upwards force anymore. So it starts to lose momentum because of inertia. Inertia is the equal and opposite reaction.
No, it's
Inertia.
It's not. There's no momentum when it's at rest. Would you agree?
There is. There's pressure. Would you agree that there's pressure right now inside this water right now?
Yeah, but there's no momentum. Momentum is just something moving that has mass, and so you multiply mass times force.
That's the thing. Everything is moving because the buoyant object is moving as well. Are you saying the buoyant object is moving without anything else moving?
It's stationary right now, though.
No, but it's applying a force on the string right now.
Sure, but it's stationary.
You could say that visually it is stationary because everything's in motion together. But if we had a long tube right now and I cut that, is that
If you cut it and it moves, then it's not stationary. But right now, it's
But my
stationary.
point is, if you believe we're stationary, right,
Yeah,
and I
yeah.
had a long tube and I cut this, what's causing that bubble to go up if everything's stationary? I mean, the
buoyancy,
ball.
gravity.
Even if it's not moving right now, there's still like a.
Yes, there's a force.
Sure.
Yes.
I don't disagree. There is a force, but
Let
there's
me
no
show you.
momentum.
Let me show you this. You guys know what a slinky is, right?
Yeah.
So I actually glued a ping pong ball to a slinky inside a water bottle, and guess what happened to the slinky? It's stretched because of the buoyant force, right? When connected to
that
the
makes
earth.
sense.
Yeah.
I agree.
Guess what
There's-
happens in
there's-
free fall?
There is tension in the string.
When I put that,
But that doesn't necessitate there's movement.
there we go. So again, that ping pong ball is glued to the slinky when I'm holding it, and as soon as I release it, that upwards push is not there anymore. Buoyancy vanishes in free fall because it's no longer connected to the earth. So again, buoyancy is a motion transfer. It's a force transfer. Because force is motion.
I
Force
would
is
say
motion.
force, but not necessarily motion. There's no motion right here, but there's force.
You know the second law of motion is F equals ma,
Correct.
which is force equals mass
Yeah.
times acceleration, which simply means matter in motion. So if you move your hand, that's a force.
Correct. But if you have opposing forces, then there doesn't need to be acceleration.
But there is
Right
no
here?
opposing forces. That's the thing. How do you know there's a downwards force, if I may ask?
Well, I mean, the easiest way is like
'Cause I can-
you drop things, they fall, they accelerate. Like, how would you explain the fact that if you drop something and you measure its velocity over time, it's increasing?
I 100% agree that there is a change in velocity
Okay.
in free fall, but that change in velocity is a loss of momentum. It's a deceleration. It's
Okay,
not an
well,
acceleration.
Well, how would you define momentum?
Momentum is an object that's in motion.
That's velocity. How would you define like momentum?
Momentum is something that I guess is losing velocity, I guess. Is either, I mean, momentum, it depends what you mean. Increasing momentum will be acceleration.
Yeah.
Constant momentum will be constant. And a deceleration will be a loss in momentum. So it depends what you mean by momentum.
Typically, momentum is defined as just an object with mass that's moving at a certain velocity. So mass times velocity. That's the quantity.
Something
of momentum.
that's moving, right?
And
Okay,
when
sure.
you apply a force to it, it loses momentum if you oppose. That
Yeah, I
velocity
agree with
back.
that, 100%.
Okay, cool, perfect. And if you apply it over time, so that time times force equals mass times velocity, which is momentum, your impulse is that like force that you're applying. It will be it'll be canceling out your momentum fully. So it's like
Okay,
those things can be kind of thought as equivalent. It's like momentum is force over time.
Okay.
So you're applying something and you're accelerating it and you're giving it momentum.
Okay, just real quick. Obviously, we have a buoyant object here. If I had a steel ball in here, that's more dense than the water. What direction would the steel ball appear to
It'll
go?
fall down.
Right? So, I can reorientate density and buoyancy. Like this, for example. What direction would you say I accelerated this vessel? To the left or to the right?
To the left.
Exactly. Because again, the buoyant object moves in that direction. The steel ball didn't move towards the container. It's the container that moved to the steel ball. And what happened was that water wasn't dense enough to push the steel ball like it did the ball, so it only appeared to swing back. The steel ball only appeared to swing because the air's not dense enough to keep it moving, right? So when we release a helium balloon here on Earth and an apple, for example, the air is dense enough to push the helium up, but it's not dense enough to push the apple. So the apple, because of inertia, it starts to slow down.
Because gravity.
And then the Earth comes up. Well, it's inertia, it's not gravity.
Wait, you
Gravity is
said-
a push.
Well, you said because of inertia, it's
It slows down, yeah, because
slows
matter wants to
down.
remain motionless.
Okay, so the apple, you're saying falls and then slows down.
It slows down. Yeah.
But then how do you explain that when you drop something, it's getting faster?
Well, because it's a loss of momentum. The more the object decelerates,
Alright.
the higher the difference in speed from the Earth and the falling object is going to be. So if you drop something from here, let's say the Earth is moving at 100 miles an hour, right? And we drop something from very low, it didn't have that much time to decelerate. So it probably only decelerated to like 95 miles an hour, right? So the difference in speed between the 100 and the 95 is only 5 miles an hour. The higher you drop something, the more time it has to lose momentum. So the higher the difference in speed between the constant and the free falling object is going to be. And that's why things appear to accelerate, because they're losing momentum. And the difference in speed between the Earth, it's increasing.
I feel
And the free falling object.
like the whole "Are you smarter than a fifth
I
grader?"
was
That's
gonna
just
say
to determine whether like what you're saying is like complete nonsense. And if you can convince us that what you're saying is true, then we fail it. But
I was gonna say this is a fifth grade level question.
Well, displacement, understanding that the bubble or the buoyant object will always move in the direction of acceleration doesn't take a genius to understand that. This is an accelerometer. You can't break it. This is physics. You know,
I've
so
never taken a physics class.
This is, again, a 10-year-old can understand these principles. If you're claiming acceleration in free fall without any reaction of this buoyant object in free fall, and you claim accelerate, that defies physics. That claim defies physics, especially if you can't recreate that force in any other vector. So if you could show me gravity accelerating this vertically without that displacement, then I'll believe gravity exists. But that's the thing. If you can accelerate this in any other vector other than free fall without the displacement of the ball in there,
Why would that be a requirement for gravity?
because that's the scientific method, measurable, testable, and repeatable.
Sure, but
It cannot be repeated. That's the thing. That kind of acceleration cannot be repeated.
Isn't me dropping this also like, okay, my hypothesis is that it's going to accelerate downwards. It's going to... So
Sure, that's what we visually interpret. Yeah, I agree.
Okay.
But if the Earth was moving up at a constant and that was decelerating, what would you expect to see?
Okay.
I mean,
here's a philosophical question. So
Sure,
I'm
sure.
gonna ask you.
Sure.
Let's say there's a person. This is the Earth. There's a person here. There's a person here. How can they both drop apples at the same time?
Yes.
How can the Earth accelerate both upwards and downwards at the same time?
Well, the Earth is not a ball. It's a level plane. It's
I
literally
see.
moving up.
Okay, so we've moved to a flat Earth theory.
Well, it's not flat Earth. Flat Earth is bullshit too, and I'm gonna tell you why.
So,
Flat.
but it's still a flat
Well, over
a level
95% of flat earthers and all mainstream flat earth channels all claim the Earth is motionless. So what that means is they also believe in a downwards acceleration. So these are the controlled opposition. They're keeping a false dichotomy with the globe Earth because they're both claiming this downwards acceleration.
So what's your understanding
The
of like?
fact is that the Earth is literally pushing up against you, which wouldn't work from a globe Earth because that would mean the
So
globe
what is
Earth
the Earth?
will have to
What's the
be
Earth's shape?
the Earth shape. The full dimensions of it is unknown, but it's a level plane. The surface that we live on,
It's a level plane.
it's a level topographical plane.
I see.
Yes.
Okay.
And it's a contained system too, because a lot of people would say, well, why don't you fall off the edge? Well, we have 14.7 psi here of air pressure, and in order to maintain air pressure, you require a solid barrier, a solid container. So the fact that we only, well, again, you have to believe in this downwards flow.
Yeah, I guess you do have to believe in gravity,
Yeah.
and you have to believe the Earth is round.
I would say the globe Earth is a religion because of that. You have to believe it. You know, nothing personal, but it's what it is.
Sounds good.
But here's my channel. You guys can check it out. I go to other universities as well.
It's okay. Don't worry.
All right.
Personally, I believe the Earth is round.
Well, why do you believe that before you go?
Well, because first of all, if we talk about the fact that, do you believe the moon is round?
Yeah. I mean, it's a circle in the sky, sure, yeah.
Well, then what about the fact that like when people went into space and they looked down on Earth? Oh, you don't believe people went into space?
Well, I assume it's being, yeah. If you believe that, then I'm not going to
I would go to like the internet and look at like videos of the moon landing, all of that.
I've been in this topic for 8 years looking for that, and I've only came across the motion of the Earth like the last 2 years because that's how suppressed it is, and that literally debunks gravity. And that's why all these motionless flat earthers are there to derail, to keep the idea alive of downwards acceleration, which doesn't exist.
This is interesting.
No, yeah, definitely, right? All right, give you guys something to think about. All right, you take care. I'm not even bringing out any other flyers or slides. I don't even have to. Like, it's literally that simple. All you need is a simple accelerometer and then a question or something to bring people in, right? That's all you need is a simple question or a statement and a simple accelerometer. That's how easy it is to debunk the globe Earth. And you see the desperation in people. You see it. Like it's pretty crazy, man. Like B. Thomas, Ron Walker, Andrew, Mr. Obvious, Mark of Melbourne. What's up? What's up? How's everybody doing? Hope everybody's well. I'm doing great. I'm having the conversations of my life right now. Oh man. It's crazy, man. It's crazy how this idea of the accelerometer came to me all random. And again, and Natalie always kind of has something to do with it. She had bought this container. What point being is she emptied it out and it was just right there sitting on the table. And I seen like, holy shit, that's a pretty cool container to use, right? To put like a buoyant, because I've been trying to create like an accelerometer. So the fact that this container was there, I was like, you know what? I'm gonna try to make an accelerometer and tie a string. I actually try to put glue on it first, like super glue. I try to super glue the ball to the string and then super glue it to the bottom. But obviously because it's in water, the glue is only gonna last so long. And I kind of wanted a permanent accelerometer because I didn't want to have to be making one every time when I come out. So I wanted a permanent accelerometer. So what I did is I cut a popsicle stick the same diameter as this container, and I basically kind of forced it down, so it's kind of like being held because it's a little bit bigger than the diameter, so I'm able to force it down, and I was able to tie a string to it and then tie the string around the ball as well, and now I have a permanent accelerometer. So it's literally that simple. Like, so far the $100 challenge is coming through. Yeah, so literally that simple for anybody that wants to go out and do this. Honestly, the hardest thing to doing this is actually having the will to come out. That's the hardest thing, in my opinion. Like, especially when you have a day off, right? And you're at home, you're just chilling, right? Whatever you do, right? You have your free time, right? Actually coming out and doing this does take a little bit of effort. I would say that's the hardest thing when it comes to doing this, because once I'm out here and set up and talking to people, it's effortless. It's just representing reality for what it is, and again, just having a dialogue about it, right? Having a conversation about it. So again, the hardest part is actually getting out to do this. It reminds me of school. When I used to go to school, the hardest part was getting up in the morning and fucking actually going to school. But then once I was at school, especially now that you're fully awake, because obviously when you first wake up, you're all sleepy and shit. But once you're at school, it's not a big deal anymore. Like, it's actually kind of fun. You get to talk to your friends, right? And hang out a bit, right? It's getting to school, getting up in the morning, that was a bitch, right? But again, I'm just using that as an example to how starting to do something or initiating something is usually the hardest thing. Usually, I'm not saying all the time, but in this case, doing activism, it is, it kind of is. It's the hardest thing to do is actually getting up, getting your car and go out, and set up, And again, once you're set up, easy. What time is it? 1:36? Not bad. Yeah, the 2 or 3 conversations I had after the first one were actually really good. The first conversation, again, the guy just completely checked out. Like, right when I brought out the curvature, because I don't know if he was talking about the horizon, maybe I think he was, or maybe I just brought it up. Point being is, yeah, once the topic came about the shape of the earth, he like completely checked out. I started checking his phone while I was talking to him, a bit disrespectful, but it's cool, I get it, Again, I literally just got the vibe that he was just trying to walk away at that point. I mean, when you're looking at your phone while I'm talking to you, I mean, it doesn't take a genius, to figure out that you're uncomfortable with the conversation, which is fine, I get it, no judgment here, when it comes to that, I get it. Shifty Eye Shady, what's up? Johnny, man, someone hasn't figured out the moon travels between the tropics every 28 days and the sun takes 6 months. Okay, who cares? Jolly Man is acting like we got the whole dimensions of the earth figured out and now we should talk about the sky, right? Because that's when the sky becomes relevant, in my opinion. It's when we have the dimensions of the earth figured out. When we have the layout of the earth and the continents and all of that, once that's figured out and we know the exact positions and sizes and all and relative to each other, then I'm all for talking about the sky, the moon and the sun and the stars and and coming up with models about it, that's fine once we establish the ground we walk on first. Because what's going to happen then is that people are going to have models about the sky, but they're all going to be under a level plane. So all the models that people are going to have are going to be off of a level. The problem is right now, people are interpreting the lights in the sky to make them fit the globe Earth model. And trying to use the visual phenomena that, of the stars and the lights in the sky, they're using that to fit the globe Earth model to try and push or to prove that the Earth is a globe. Again, they're trying to prove the Earth is a globe by looking at the sky, and that's where the misdirecting is right there. That's where they're misleading people. And motionless flat earthers that are entertaining this shit are literally falling into that false premise. Again, giving any credibility to the sky to try and prove the ground you walk on, it's a trap. It's a trick. Again, it only benefits the globe. Why? Because the globe Earth has nothing. So if they could get flat earthers to debate them on something that has nothing to do with the shape of the Earth, well, now it's making it look like the globe Earth does have something. Because look, they're arguing, they're debating, you know, the stars and how they work, you know, on a globe, and how it doesn't work on a flat Earth, and the flat earthers are doing the same. And now you're giving the globe Earth some credibility. Now you're giving the globe Earth a leg to stand on by entertaining these fucking observations of the sky. Because again, if we just focus on the ground we've walked on, we focus on the physical dimensions, the physical measurement of the Earth, that's what's going to show you. That's what's going to prove that the globe Earth is impossible. And only then and there that I'll entertain conversations about the lights in the sky. Until then, it's fucking bullshit. Literally. Hi. You want to give this a shot? Okay. Oh, is her here? So, very easy. So the challenge I have, this is be considered a simple accelerometer, and the reason why is because this device detects acceleration. So I have water inside this container and a buoyant plastic ball in there, right? So it doesn't matter what direction I accelerate this, the ball will always get pushed in that same direction. I accelerate. You know, when it's at rest, the ball will always react, right? Always, 100% of the time. So the challenge is, can you guys accelerate it from here to this line in 1 second without the reaction of the ball? In other words, without the ball moving.
Oh.
If you guys can do that, then you guys win $100.
But you can pick it up and stuff.
You can pick it up too, but it has to stay vertically, and you have to accelerate it from here, but without the ball moving.
Oh, like, girl, that's impossible. Physics.
No, it has to stay vertically. It has to stay vertically. The other way, yeah.
It's impossible?
Yeah, you got it. It is impossible.
It's impossible.
Yeah, it is. Why do you think it's impossible? Because it is impossible.
Because of physics.
And yeah, I mean, pretty much. It's like me asking you to walk on water.
So you can't win the $100.
You can win the $100. That's a kind of a trick challenge, but here's the real reason why I'm doing this. When I'm holding this at rest right now, and I release it, do you guys believe it accelerated down towards the Earth by gravity? Yeah? So, again, when I actually did this in slow motion, just to prove a point, when I actually accelerated one of these down, and again, you see the reaction of the buoyant ball. Which one of these two would you say I actually accelerated? Down. The one on the left or the one on the right?
The one on the left.
You think this one accelerated down?
Well, you dropped it, right?
Yeah, but one I actually accelerated down physically.
Like you.
I grabbed it and accelerated down.
Oh.
Which one did I actually accelerate down? You think this one's the one I accelerated?
Yeah, because why would, if that's buoyant, then why would it go down?
Because buoyancy always follows the direction of acceleration.
Yeah, but when you go like this, it's not going to go downwards because it's buoyant. So it's going to
Well, it's because when you're holding it like this, you have to actually accelerate it kind of fast because you're connected to the Earth. So what this proves...
Yeah, it can't go down.
Well, but it could go down when I actually accelerate it down.
If you do like this.
Yeah, so the fact is, buoyancy shows you the direction the force is being applied because matter cannot move on its own.
Is this for class?
No, it's not for class. It's just pretty simple thing. So, but my point is,
Are we instructed?
Is this
So-
for YouTube?
it is for YouTube. So the point is, gravity is not pulling you to the ground. It's actually pushing up against you.
And there's no money prize.
It's just knowledge.
So it's just a
Knowledge.
scam.
Not really.
It's kind of a scam.
It's a real.
False advertising.
So point being, gravity
You
is
get knowledge through false
Gravity is not a
advertising.
pull, it's a push, and we've been lied to about this idea of objects accelerating down towards the Earth.
What?
Wait, what does that have to
Wait, what is?
Yeah, so this is an accelerometer. It always detects acceleration, but in free fall it doesn't.
Wait, what is your
Wait, who's
what is
lying?
this thing?
Yeah.
So you
What
guys
is this
believe in a
for?
pulling force of gravity, right?
Yeah, of course.
Yeah. So the fact is, it's not the Earth pulling you down; it's the Earth pushing up against you. So the reason why you're stuck to the Earth is because the Earth is pushing up against you. You're not being pulled out towards you. That's the fact of the matter. That's why I'm out here. Yeah. So the Earth is literally moving up through space like this, and we're all standing on it. So you guys believe the Earth is a ball, right?
Wait, like.
Oh, you're a flat earther.
Not a flat earther. But I also don't accept the ball Earth.
So what do you think it is?
The
Like
Earth is a level plane because it's in
so
motion.
it's flat.
Well, it's not flat because flat has no orientation. Flat is just a.
Constantly accelerating upwards.
It's not accelerating. It's a constant motion.
I
Because if
do
it was
not-
accelerating, your weight would be increasing.
No,
Why do you keep shaking that, if I may ask?
Because it's fun, and you don't
Okay.
have. This is like I don't believe that the Earth is not a ball. I don't believe that it's a flat plane.
Do you believe it's a ball?
Of course.
So if the Earth was literally moving up,
Have you ever watched like the Jubilee videos of like flat earthers versus like?
yeah, that's
What do you think of those?
That's a false dichotomy because over 95% of flat earthers, in my opinion, mainstream flat earthers, all claim the Earth is motionless. So they believe in a downward acceleration too, just like gravity. So they're keeping the whole idea of gravity alive, which is keeping the whole globe Earth idea alive. That's why it's a false dichotomy. So that's the fact.
What made you think that like the Earth isn't that?
Well, it's not a thought. It's practical physics, like you said. Buoyancy cannot exist without a force.
Yeah, but
Buoyancy cannot exist without a force.
gravitational
Definitely.
pull is a force.
Well, I don't know if you knew Einstein's theory of relativity. He claims that gravity is not a force. So he claims it's a force. It's not a force, but it acts like a force. So he double speaks. So it's all bullshit, pretty much. All these theories of gravity. That's why they're
So
theories.
yeah, everything's a
believe it?
theory.
No, is wood steel stronger than wood?
And it depends on. It depends
Can you
on the
breathe
property.
water?
What does that have to
Does
do
fire
with that?
burn? Those are all facts. They're not
But those
theories.
Those are different things.
Those are
though.
facts about our physical reality. Fire burns. That's not a theory.
But
That's a fact.
what does that have to do with breathing water?
That fact is that you can't breathe water, you'll drown. That's also a fact. That's not a theory.
But those things are so unrelated.
No, I'm talking about, she's trying to say that nothing could be proven, that everything's a theory. I'm trying to
She
say
didn't
that.
say nothing can be proven.
She said that everything's a theory. You did say that. Or do you take that back?
No, I didn't.
Okay, yeah.
We didn't say everything.
So physics,
We didn't say everything.
physics,
We said 'cause it's a theory.
physics proves things, basically. Understanding how physics works.
Are you vegan?
Oh yeah, I'm vegan. Yeah, I don't eat animals.
That's good.
Yeah. I think torturing animals is.
I'm vegetarian.
I would say that's no different than eating.
I'm allergic to cashews, so
Oh, okay, I see.
yeah, a lot of vegan foods have cashews.
I see.
Do you go here
Oh no.
to the school?
No, I don't. I just challenge the current narrative. Because this is the biggest lie on earth. I know you guys might think it's funny, but the fact that there is no physical downward
I didn't laugh.
acceleration, for whatever reason, this is the biggest lie
I
on
just
earth.
said it's a scam.
Well, it's not a scam.
It
Well,
is a scam. It is a scam.
Well, it's a
The
scam that
definition
you
of a
believe
scam.
objects accelerate down in free fall.
It's a scam that you said if you're smarter than a fifth grader, promise $100.
Well, I didn't promise $100.
On your sign, it says if you're smarter than a fifth grader, you can get $100.
Are you smarter than a grader? It says $100 challenge here. I don't know if you missed that part.
It's a challenge.
It's a $100 challenge. Yes,
So
you
we did the challenge technically.
yeah, and you failed.
I'm smarter than a fifth
You had to
grader.
accelerate
I never
it.
failed. Right? We
The
never
challenge
failed.
was accelerating this without
But
displacement.
you said it's not possible.
It's not.
So it's not really a challenge. It's just something that's not
It's just something
possible.
to start a conversation. Sure,
So
you
you're
could say
just
that.
starting a conversation. So what's the challenge?
The challenge is that gravity doesn't exist as a pulling force that can accelerate all matter simultaneously.
But if they challenge, there's usually a way to win, right? Otherwise, it's not a fair challenge. It's
Sure.
not a test.
Well, you win knowledge.
So
That's my
what's
point.
What's your actual test?
Yeah, knowledge.
There is no test.
The test is knowledge.
So if I've gained this knowledge, right? So I won the challenge, right? Because I heard
No, you didn't win the
I won
challenge.
the
You
challenge.
won the knowledge. You failed the challenge, but you won the knowledge.
The challenge was to receive the knowledge.
No,
so
the
I
challenge.
received the knowledge.
No.
Therefore I get the $100.
No, the challenge was to accelerate this without displacing.
That wasn't the challenge because it's impossible.
Exactly.
So you said a challenge is something
A
where you
challenge?
receive the knowledge, right? So that's the challenge. So if those are the parameters of what the challenge is, I did the challenge.
You did it, but you
I
failed
did it. I
The
didn't
fact
fail
is,
it. And you didn't say win the challenge. You just said $100 for doing the
challenge.
challenge.
Yeah, I explained the challenge.
$100, do the challenge, did the challenge.
I explained
I
the
get
challenge
$100.
before you started, though. If you can accelerate this to here, and I said, if you could do that, then you win the $100.
But you said the challenge
I can't
is
fit all
the
that. I mean, I could fit it, but it won't
And
be
you
easy.
never said
right?
win the challenge.
I mean, that's what a challenge is.
Well, if we're talking about winning, then if you're saying a challenge is something that can be won,
well, that's what
this
I did.
can't be won.
That's what I asked in the beginning, though. If you can accelerate
so
this, then you win.
This is a scam.
Okay, sure, it's a scam. Sure, yeah, it's a scam.
I'm just saying, if we're going off technicalities.
Sure, it's a scam. But you've been scammed as well about believing in the ball Earth. That's the biggest scam on
I'm
Earth.
not bothered about it.
Oh,
Does
it's
it
fine.
really feel like it bothers you? Like, if the world was a circle, would you feel like your life
If you
would
were
change?
being lied to about your entire existence and the nature of the Earth, and your existence within
But
the
it
Earth,
doesn't change my life.
well, it does.
How?
Because we're living a fake life right now of monopoly. It's all made up. Money doesn't even have value. I don't know if you knew that. But people
I don't
believe.
believe that.
Exactly. And why do people agree to a $50 trillion debt currency? Why do people agree?
Because
They just
the
believe what they're
system that
told.
was agreed
Exactly. Because people are just too ignorant to
Yeah,
the
but
facts, and people just do what they're told. People are too dumbed down nowadays because they believe Earth is a ball. It comes down to that.
But I don't think like money has to do with the Earth being a.
Well, it just shows. It just shows people that believe in the globe Earth, in my opinion, just shows that you're willing to believe authority over your own common sense. And if you're willing to do that, then you're going to be easily controlled about other topics as well. So it's a cheap shot on our common sense. It's not necessarily.
Honestly,
Yeah.
the Earth being a ball, being
What
a flat, doesn't
benefit
affect.
would authority have?
Well, I mean, if they could get a bunch of people to do everything that they're told, I mean, what benefit? I mean, they're literally controlling people, and people just believe
What
everything
does it
they're
have
told.
to do with the Earth being a ball? Are you
Well, like
saying
I
it's
said, it's a cheap shot on our common sense when we're very young to basically give away our authority to in favor of our common sense. That's what it's about. It's a cheap shot on our common sense.
I don't think believing one thing means you believe other things. I can drink water. It was lovely to meet you.
It's always good to start a conversation.
I enjoy conversation.
I go to universities all over the place, so you guys check it out. You guys want to take it?
It's okay.
I'm good, thank you.
You guys want to see yourselves?
I can see myself. I'm an actor.
Good for you.
Thank you.
Just like the astronauts. You might be a good astronaut if you actually went in that field. If you're an actor.
I don't think they let me in space.
I mean, if you're a good actor, I think you'll be a good
I have
astronaut.
to kind of study different things. But I would love to go to space. Why not? Oh, you know that dog? I want to be like. What if this is all a simulation?
It's not.
How do you know? How can you prove it?
Because a simulation would indicate that the laws of physics don't exist.
See, my character and the person controlling me took my job.
A simulation would indicate that the laws of physics don't exist, but the laws of physics do exist. So a dream could be a simulation, but in a dream you can fly, you
Dreams
can
are
dream.
so real.
This is as real as it's gonna get. This is it.
Right on.
All right.
Right on.
Stay
Take
vegan.
it.
I like that.
Yeah,
Yeah.
stay vegan.
Oh my God! Like she was shaking it so hard that it untied from the base. So I'm gonna go ahead and call it now.
Well, no. I called my brother. He's a physics major.
Okay.
Can he have a shot at this?
Is he coming?
He's gonna be here in like literally 2 minutes.
These two girls just messed up my accelerometer. They were just shaking it pretty
Oh.
drastically, so I'm gonna have to redo it, but not today. But but I guess we can still have the
Could you
conversation.
do like a more theoretical? You make your point. And he's
Sure.
Yeah, he's like right here.
So wait, is he on the phone or is that him?
No, this is my brother.
Oh, is this your brother? Okay.
Not related.
Brent, we look like
I always like walk around and I see this.
Oh, really?
You gotta hurry up. I'm not.
Okay, because
He's
is
like 1 minute away.
1 minute
I
away.
just want to understand like the point.
Well, I'm doing a $100 challenge, but the conversation I had before, they were kind of shaking this pretty crazy, so it kind of messed up my setup here. But basically, what I'm going to show, I'll just show you this.
And a fifth grader could figure this out.
Yeah, it's just very simple physics. So when you have a buoyant object in a container like this with water, that's considered an accelerometer. And the reason why it's considered an accelerometer is because it detects acceleration. So regardless of what direction I accelerate this bottle, the ball will always get pushed in that direction I accelerate 100% of the time. That's physics, that's fact. You cannot accelerate this without that motion of the ball being pushed in that direction, right? So let me show you this, because I want you to understand. Here, look.
Have you talked to this guy before?
Yeah, he talked to me already.
This was
Yeah. So since we understand that the buoyant object, in this case it's the ping pong ball, always gets pushed in the direction of acceleration, what direction would you say I accelerated this container? To the left or to the right?
Well, based on what I just saw there, if it goes to the right, then you accelerate to the left. Right? No, why not?
Because the buoyant object, because it's less dense than water, when I push the bottle, the bottle pushes the water.
This is the ping pong, right?
This is the ping pong ball. So when I accelerate this to this direction, for example, the bottle pushes on the water, which creates a pressure gradient, and the water, because it's more dense than the ping pong ball here, it's able to push it in that same direction. Something that's more dense than the water will not be able to get pushed by the water, so it will only appear to swing back. So in this case, I accelerated this container to the right, because we could see the ping pong ball react to that motion, to that acceleration, right? The more dense object didn't move in that direction because the water wasn't dense enough to push it. So the container made contact with the ball, the steel ball. The steel ball didn't make contact with the container. Does that make sense? So one force created this separation of matter, in other words, density and buoyancy, right? So point being is, the buoyant object will always get pushed in the direction I accelerate 100% of the time, right? So when I actually accelerate this down, like actually accelerate it down, we actually get that reaction of matter. The buoyant object gets pushed down in the direction of acceleration. Which one of these two would you say I actually accelerated down? The one on the left or the one on the right?
What we're arguing now is that the one on the right.
Yes, that's the one I actually accelerated down, because we see the reaction of the acceleration. The one on the left, however, is so-called free fall, which people claim is acceleration. The fact is that if it was acceleration in free fall, matter will react to that acceleration, because that's what accelerometers do. And when you have solids, liquids, and gas in a container, they will always reorientate relative to the direction of the force. So, in other words, people are claiming or believing that when you release an object into free fall, that Earth pulls it down towards the Earth, but the fact is, it's the Earth pushing up against you. So
Okay.
you're not being pulled down towards the Earth. So yeah.
Okay. Let him handle this.
All right. So you're describing something that led Einstein to go into
Theory of relativity?
Yeah, the equivalence principle, right?
Yes.
Yeah, okay. So there is no difference on a small scale between the Earth accelerating up and us falling towards the Earth. But I guess two questions for you. With your, I haven't heard your full theory.
Demonstration, sure.
Yeah, your explanation, how does it explain why light falls under the influence of gravity?
Do you know, well, light's not even a mass.
Exactly.
So I don't even know. So I don't think light is affected by forces, in my opinion.
It's not affected by forces, but it falls under the influence of gravity, right?
Well, I would say that's just theoretical. That's what we're told happens in space with light bending and stuff like that. What are you talking about?
It's measurable, right?
Okay, sure.
So there's been experiments done to demonstrate that, similar to your explanation with the Earth accelerating upward.
Well, it's not accelerating, but it's a constant motion. But sure, I get what
do you mean it's not accelerating?
It's not accelerating. So a lot of people think the Earth has to be accelerating because, but the fact is, matter has inertia. So everything has inertia, right? Matter wants to remain at rest. An object at rest will remain at rest unless there's an external force acting on it, right? That's the first law of motion. So that which contradicts
Newton's law of motion, which is from the 1600s.
But it's a law that's applied today. That's my point.
On Earth, maybe for kinematics, but not on celestial bodies.
So we have to go into imagination land. That's what you're saying now. But because here on Earth, we can't demonstrate.
Well, here on Earth we can, right? Because Einstein's theory actually predicts like light curving around planets in a way that Newton's gravity doesn't, right?
Sure. But that's him claiming that gravity is a flow of space-time, which is what he claims, down towards the center of the Earth. When this flow that he claims is there, first of all, cannot be physically measured, because
yes, it can actually.
How did they measure it?
How do they measure the flow?
Downwards flow.
Well, that's what we experience as gravity. But if you want to, we know that gravity, we can measure how gravity is just space-time being distorted because of things like gravitational waves. Do you know what gravitational?
I've heard of gravitational waves. Right. I would say they're just theoretical, but
No, we've measured them, right?
How did you measure them?
So there's these facilities, right? And basically they have laser beams, right? And when you line up laser beams, right, so that their wavelengths are perfectly aligned, right, you can either have constructive or destructive interference, right? Which means that if they're aligned in a way so that one peak is at another wavelength valley, right, like this, the two lasers will cancel out, right? And so no light is formed.
Whereas if you perfectly align their wavelengths, then the amplitude will be twice as high, right? Because the peaks are adding, right, versus subtracting. So basically what happens is we measure these gravitational waves by getting two laser beams pointed at each other from like miles and miles and miles apart. And basically we can measure the stretch and pull of these gravitational waves as the two laser beams are actually physically being pulled apart. We can see that they oscillate between constructive and destructive interference.
So that proves to you that there's a flow accelerating objects down towards the Earth.
No, it's what is called gravitational waves.
So that proves to you, that explanation you just gave to me, proves to you that when I release this object, it accelerates down towards the Earth. Right?
No, it proves to you that you can measure gravitational waves. That was your initial question. You have to let him deduce.
Well, let me be more specific. How did you measure a downwards flow of gravity?
Well, I measured downwards flow of gravity.
Downwards flow of gravity that makes this object go to the ground.
What? 9.8 meters per second squared.
So I wanted you to get there. So you're measuring a change in velocity. That's what you're measuring, right?
That's acceleration, right?
Yeah. It could also be deceleration. I don't know if you knew, you could look that up.
Yeah.
A change in velocity can also be deceleration. So what you're measuring is it's a change in velocity, but it's a deceleration. So if the Earth is moving,
it's not.
So okay, say
if
right
I
now.
drop an object right now, it accelerates to the Earth.
No. So if we're moving
gets
up
faster.
I agree with that. So if we are moving up at a constant right now, 100 miles an hour, we'll say, theoretically,
you wouldn't feel anything.
You wouldn't feel a pressure under your feet?
No.
Why not?
Because how come when you're in a car with the roof closed, right, going on the highway 100 miles an hour, you feel it's an inertial frame, right? You can't really prove that you're in a car driving 100 miles an hour unless you see that object.
You want to know
flying.
why you can't prove that at a constant rate? Because you're connected to the Earth. So you're already experiencing a constant force.
No,
in order to
you just said constant force, which is different than a constant velocity, right? So a velocity is not an acceleration.
Yeah.
An acceleration is a change in velocity, like you said. That was your
change
definition,
or deceleration.
So if you're saying that Earth is moving at a constant speed, then we would move at a constant speed, and then what happens when you jump?
You have inertia.
What do you mean you have? So based on your definition, right? It's moving at 100 miles an hour, like you said.
We don't live in a frictionless environment.
Okay.
You think matter just
Hold
moves
on.
infinitely by itself, right?
I'm gonna deal with your
Sure.
parameters.
I know where you're going, but go for it.
It's moving 100 miles an hour, right?
Sure, hypothetically.
We're
sure.
moving. That's what you said. So we're moving with it.
Yes.
Also at 100 miles an hour.
Yes.
So then, if we jump up 2 miles an hour, wouldn't we be now going 102 miles an
You
hour
are.
and then just flow out?
No.
into space forever?
As soon as your body, that force is no longer there, as soon as you jump up, you did accelerate up.
Well, you were using Newton's laws, right? And so
I'm just using practical reality.
If Earth is accelerating us at a certain point, we start moving with the Earth completely. Why? How come when we jump up, we suddenly aren't moving with the same speed?
Because you automatically, once that force underneath your feet is no longer there, you start to decelerate, lose momentum.
You're using like your visual world. If I push an object, once I move my hand, right? It's not like the object just stops. It keeps following.
Yeah, it has to decelerate. So if you're going 100 miles an hour and you let go of the gas, it's not going to completely stop to 0 miles an hour. It needs to decelerate. You need time to decelerate. It goes from 100 to 99 to 98 to 97 to 96.
Well, the reason the car decelerates is because of friction.
Yeah. Inertia is friction, but it's not air. It's the background medium that people claim is gravity.
Well, I don't.
That's just inertia.
Even so, even if I guess what you're arguing is that, right? So we leave the Earth and the air, right, is what slows us down.
No. The air slows you down as well when you're moving horizontally. But when you're moving vertically, again, matter has inertia, meaning it resists motion. So matter wanting to resist motion is what makes objects appear to go down, because once that force is no longer pushing up on the object, it starts to lose momentum because of inertia. So matter has a resistance to motion.
What underlying principle do you have to justify inertia? Is inertia the basic principle of
the fact that there's no displacement in free fall, because if people claim acceleration in free fall, there should be displacement, but the fact that there isn't shows that there's a deceleration.
What do you mean there is no displacement?
So when I accelerate a container with a solid, a liquid, and a gas, like I don't know if you've seen it.
He's saying the ball doesn't move in free fall, whereas if there was acceleration, it would be pushed down.
Yeah, look, when I accelerate,
but when you jolt it down, it pushes down. So
yeah, look, when I accelerate, again, I'll show this again.
Yeah.
There's a reorientation of matter. The line, this vertical line of the string, shows the vector, right? The vertical vector of gravity, right? But I'm saying the vertical vector is not down, it's up. My point is, when I apply a force, I can change the vector.
Well, okay.
When you accelerate
this
down,
experiment is independent of gravity.
Well, it's a force. This is force.
That demonstrates buoyancy.
What is gravity? Let me ask you, what is gravity?
Let him finish his point.
Yeah.
He's making a great point.
That demonstrates buoyancy and density, right? Density is independent of gravity. It's mass, right?
Well, with density, sure, it's mass. But the motion of density, what creates that?
You mean the motion of density?
Yeah, the apparent
density is an intrinsic property of matter.
Yeah,
It doesn't. It's not created. I mean.
So you're saying gravity pulls this to the ground and then pushes a helium balloon up? So it's gravity is acting in two vectors?
Gravity pulls a helium balloon down in the same way that it pulls that water bottle down. But the reason that a helium balloon will float, whereas that falls down, is because the buoyant force inside of the helium balloon outweighs the force of gravity, right? So there is a force of gravity pulling the balloon down, just like it pulls that bottle down. But since the density of helium is so little, right, the buoyant force created outweighs that downward pull.
Bingo.
I agree. So buoyancy, and I can recreate this, I'll show you right now with a helium balloon.
Okay.
Buoyancy is an effect of a container that's in motion, and the reason why we have a buoyant effect is because the air is more dense and pushes it in that direction. But the air also
Watch
has...
this.
No, can I finish as well?
Sure.
So the density of the air being more dense than the buoyant object will push the helium in that direction, but the air also has to be moving in that same direction.
Yeah, watch this. So can I ask you something?
Sure.
When you drop this container, and your baseline of relativity is the container itself, does the container accelerate at 9.8 meters per second?
No, there's a deceleration of 9.8 meters per second.
So it's the same thing, right?
Well, it's a deceleration, not an acceleration.
It's the exact same thing.
Well, it's not the same thing because your theory. No, I'm going to tell you how it's different. Because you guys believe the object moved down towards the ground. I'm saying that it's the ground that moved up towards the object.
Okay,
it's the complete opposite.
So wait.
It's not the same.
The Earth is a. Do you think the Earth is a sphere? Or do you think it's
No.
Okay.
So that's my point. So here, look.
Okay. So we're getting
somewhere. Yeah. So
I knew it, bro.
I recreated buoyancy right here in a cargo van. So I changed
real quick. How do you then explain gravity on the moon where there is no air?
Now we're talking about imagination reference frames.
No.
Imaginary reference frames.
You are. Wait. At this point, we need to deconstruct your worldview. Are you an empiricist?
I'm a realist. I go with what I can prove things here on Earth.
What's it if he just actually pointed
out?
No.
Let me just make this point real quick.
Okay,
and then
I'll
we'll
let
go
you
to the
make
next
this point.
because we're talking about buoyancy.
Then we'll break down the theoretical framework of your theory.
So buoyancy here, I can
got this.
prove in any direction when we have a container and a helium balloon inside that container. When I accelerate the container, the air, the motion of the van creates a pressure gradient with the air because the air wants to remain in its position because of inertia. But the van, because it's moving, it's pushing the air in that same direction. Now the air, because it's also moving, it has pressure because that's a push, can push anything that's less dense in that same direction. That's what buoyancy is. So when you release...
Could you define pressure and could you define gradient?
Yeah, pressure is a pressure gradient is simply a container that's in motion.
No. Just define
a pressure gradient. So
just pressure and then gradient.
Well, pressure again is you require a container.
No,
and then you require a force.
There is a definition of pressure that I don't think.
What's your definition of pressure?
It's a force per unit area.
Sure. What's force?
Mass times acceleration.
What does that mean?
Okay, so mass is a property of matter,
yes.
Right? And acceleration is
it's
the
motion.
Change of velocity. Yeah.
Right. So force equals mass times acceleration, which simply means something that's in motion, right? Something that's moving, right?
It doesn't have to be moving.
Well, it's not a force.
If there's equal forces acting on a single object.
If F equals ma, how can a force not be moving?
Well, the force would move in the absence of another force. There can be multiple forces acting on an object.
Yeah, but all those forces have to be in motion to be considered a force.
Sure, but the object itself isn't in motion.
I'm exerting a force on him.
Yeah, but his resistance is greater than the motion you're applying.
It's equal. It's my leg. My leg is pushing
your
off.
hand. Where's
There's
your
no motion.
Okay, when you're
I'm pushing off the ground. I'm like a cantilever.
When you're pushing, when you're pushing something like this, is your hand moving in this direction, or in that direction? When you're applying a pressure, even if you're not moving it. What direction is the force being applied?
Let me abstract.
In that direction, right?
Could we abstract? Could we abstract this really quickly?
Sure.
Would you be okay abstracting?
Sure.
Okay. Can I ask you what the basis of your worldview is? You say realism. Can you explain to me what that means?
My basis is what practical physics has to show me. That's what I go with.
So you're an empiricist in this way. You observe things, and if it is physically observable,
measurable, testable, and repeatable. It has to go through the scientific method.
Can it be measurable by like very technical and precise instruments?
When people talk about measurements just by looking at something, that's not a physical measurement.
Okay,
if you're just looking at something and coming up with calculations based on what you're just seeing, that's not a real physical measurement.
Wait. So what's a real physical measurement?
So a physical measurement will be having a substance like this and actually seeing the reaction of it and measuring it.
You just said seeing it doesn't prove.
Well, I'm not just seeing it. I'm able to touch it. I'm able to manipulate it. I'm able to change the vector.
So you're saying
I'm able to do all
things that
that.
are only tangible to your own hands and your own
and
immediate experience are what define and inform your worldview?
Yes.
You realize how impractical and antiquated that is.
I say that's the most practical.
So in this idea, you would agree with, I guess, the earlier physicists like Aristotle, and you would agree that everything that I can see informs my worldview, and anything that I can't see is some immaterial, intangible object that just doesn't
that's
exist.
the difference between objective and subjective.
It's
Yes.
actually not, because you are actually describing the purely subjective experience. Because
I'm actually surprised.
No, you're not.
I'm objective.
Actually, I will explain to you what is objective and what is subjective.
Please.
Objective is what exists independent of our viewership and understanding of it.
Sure.
So, if let's say
So
that
like this accelerometer,
okay, no,
sure.
But let's say that I see this and I'm saying it doesn't move. What are you talking about? I don't see that move. What is there an objective reality
If I
underlying
had
both of our
if
experiences?
this was a long tube and I cut the string,
wait, dude,
there will be motion.
I don't see that ping pong ball move at all when you move it. I'm saying I don't see that.
What do you mean?
I don't see it. So it doesn't.
So when
move.
I'm moving like this, how do you not? I would say
I
you're.
don't know. I don't
I
see
would
it.
say I would say you're a reality denier now.
No. Because you just said subjective is
Would
what-
you say? Would you
No, no,
agree
no,
with
no,
him
no,
that
no,
you don't
no,
see a
no.
movie?
Let me get my point. Let me get my point.
Sure.
You just said that what is objective is what I see, and I'm telling you,
What
I
I
don't see
can
that.
measure, not just see, measure. Too.
I can't measure it move. So, but my point is there can be this disconnect between what we observe and what is actually real. And you're saying reality is what you observe. You only
Well,
observe.
not just observe, physically test as well and manipulate.
The exact same thing, actually.
No, it's
the
not.
exact same thing.
No, it's
what you
not.
observe and what you see and manipulate. Okay, fine. What you can see and manipulate. And I'm saying, oh, I actually observe a different version of reality that I can both see and
Now,
manipulate. But
You
there
can
is a-
manipulate gravity like
no,
that.
no, we're not talking about gravity. We're talking
That's
about
what I'm
we're talking about the theoretical frameworks of both of our worldviews.
Yeah, your
So-
worldview.
No. But
You believe
can
in
I-
objects
can I get
accelerating.
this?
Sure,
Can I get
sure.
the subjective
Sure.
point out because I think it's so important.
Sure.
So I say I'm moving this.
Sure.
Just for I do see it move. I will acknowledge that. I'm not a reality denier.
Sure.
But it is also likely that I can say, wait, no, this isn't moving. The whole world is moving around this. Why is that not valid? Because in my subjective experience, I'm seeing this ball move and I'm saying, wait, this ball is the only stationary thing. The whole world is moving around this ball and we are shaking. That, as you would define it, would be real. That would be a subjective experience. I am saying that there's a disconnect between what you and I view as real. Therefore, there must be an objective reality that is beyond our that is beyond our immediate
Our
experience
vision,
of reality.
yeah.
Right. So,
Beyond our vision, yeah.
how do we arrive to this objective? You say that it's from experiencing, touching, and manipulating objects. I'm saying it's from understanding the underlying principles and theories and truths of objects.
That's the only way to do that is by playing and manipulating the object.
Absolutely.
It's also,
Yeah,
it's also by checking with others.
Yeah.
Right?
Anybody can
Like,
recreate this.
You're arguing that the Earth is flat.
Not
That
flat,
would-
level.
Level?
Level. Yeah, the Earth is not flat, and I'm gonna tell you why. Over 95% of mainstream
Let's
flat
not get here.
earthers.
Let's not get here.
Okay.
Over,
This is
just real
important.
quick,
You gotta expose logic flaws.
because I don't want people to pigeonhole me to flat earthers because I'm not a flat earther. Over 95% of mainstream flat earthers believe in downwards acceleration as well because they claim the Earth is motionless, and that's literally the false dichotomy. Flat Earth versus globe Earth is no different because they both believe in this downwards acceleration. So I'm not a flat earther. Flat earthers are dumb as fuck and stubborn as fuck. So
Okay.
just want to put that out there.
Okay. But you also claim to believe in an objective reality.
Well, yeah, I accept reality.
You accept reality.
I accept reality.
But you deny things that are
I
objective.
deny theories that contradict my reality.
But he just described to you a theory of gravitational waves. That was going to be my point. I said, well, you can see and manipulate objects with technical instruments, with more sophisticated instruments than our eyes and hands. So how can you deny reality when we are actually experiencing, envisioning, and manipulating reality with very technical and precise tools? Does that not constitute reality to you?
What about
Well,
the
I would say you're just believing all of these tests that they're doing.
Well, no, but you can
because you can't
observe-
recreate
you
them.
can observe these
What about
tests.
your phone?
So yeah, I'm glad you brought it
Like
up.
radio waves, things like
No,
that. You
so
can't
my
see,
phone.
observe,
Did
right?
you know that everybody's cell phone, everybody's smartphone has an accelerometer built in? That's why you're able to turn the force grid because it detects a force, a vertical force, right? So when you download an acceleration app and you accelerate this phone, it registers 1G obviously here on Earth, but when you accelerate it, it goes to 2, 3Gs, 4Gs, depending on how hard you accelerate. It registers that force in any orientation, right? When I put that accelerometer into free fall, it goes from 1G to 0.
I think his point was more
so
so that
it shows a
that-
deceleration.
No.
How is that not a
Wait,
deceleration?
Don't get into this. I think his point was more so that, like, your phone is you look at it and you're like, this is a black box. How the fuck does my phone work? You cannot see the inner computation of your phone, calculate some list of data to create a certain output. You cannot physically see that or manipulate it without these tools. So if you were to deny reality at the level at which you cannot actually see and manipulate it physically, then how can you explain things like your phone? How can you explain things like lights turning on?
I can get into the specifics of a phone and study them and actually do it myself. Well, as I can't talk about gravity and recreate gravity. That's just nobody can do that. Not even the.
But I was gonna say.
Yeah, I would say you just believe that.
No, but you're saying you just believe that. There's a
No, I
contradiction.
accept it because I can use it and it works.
And
obviously,
you just pointed out an experiment.
The different-
Okay.
you believe objects accelerate down with no physical measurement of that.
There is. He just provided that.
The same thing you're saying about your phone is what I'm saying about
Precisely.
like the theories that I use for gravity, right, versus yours. Even if we disagree, right, there's no difference in the way we experience that gravity, right?
Yeah, I guess I would say. Well, here's sure. We observe things appear to fall down, and yeah, you can interpret that as acceleration, and I'm saying it's deceleration. How do we prove it's one or the other? I guess that's my point.
Whether or not we agree on the fundamental properties of gravity doesn't matter, right? It's
Well,
like
that's the
our
whole
days-
point of this
No,
subject.
hold on.
But yeah, sure.
It's like it doesn't matter. It doesn't impact our day-to-day life, right? Gravity will still affect us in the same ways. However, I think the ultimate goal is A, to understand, as he said, fundamental properties and actually understand how things work, and B, in that describe as many things as possible, right? So one question I asked in the very beginning, you haven't answered, right? With your version of gravity, right? Explain the curvature of light.
I don't need to explain. That has nothing to do with when talking about acceleration and free fall.
But light curves.
I would say you just believe that.
Under
That's
the
something you
influence
believe.
Of gravity.
Tell them how you observe that. Tell them the experiment you just mentioned earlier.
There's another. So Einstein explained that through general relativity, and he predicted with that. And 100 years later, after he predicted, he was dead. He said at a certain time, right, we'd be able to observe light curving around Mercury, right? And scientists were able to actually observe that the light was traveling. Light travels in a straight path, right? That's one of the properties of light. Yet it was curving around Mercury. So how else would it do that? Unless it was following the straight path of a bend in space-time.
Right. Honestly, him claiming to see light curving around what Jupiter was it? Mercury. Yeah, I don't see the correlation from that to physically measuring a downwards acceleration.
Well, here's what his point is. I think that he's trying to make the argument that you actually do observe these things under your parameters of reality.
Right.
You can observe these experiments if you have technical enough equipment. You can measure light bending around Mercury. So under your version of reality, where you say I need to be able to see and manipulate it, people are already doing that. So how can you deny it? And you say you deny it because, I'm not seeing it. They're just telling me what to believe. So if I were to give you, let's run a hypothetical.
Right.
If I were to give you these exact same instruments that these scientists have access to, and the exact same data, and the exact government funding they have access to, and you were to conduct your own experiments, and you saw light curving around Mercury, would you believe in our theory of gravity? How would you?
First of all, if I seen light curving around Mercury, I wouldn't jump to that objects accelerate down in field. I would just say that's a phenomenon that if it was there, which I don't think it is, you guys just believe it. But if it was there, I don't think it proves anything about the Earth we walk on, in my opinion.
But if
I'm being honest.
Okay. Let's say you ran more experiments. Let's say that you had.
Here, let's talk about basic principles real quick.
I think this. I don't think.
I mean,
okay.
It's not going to, but I have a very important point to make. Let's say you had access to all of the science.
Before you go, I just want to make a.
Thank you.
You did very well, man. Good job.
Right. You're talking about basic principles of our reality, right? Would you agree that this is a basic principle, that this will always displace in the direction I accelerate? Yes or no? Is that a basic principle of our reality? Because if you say no, I would say you're just a reality denier.
A basic principle
of our reality.
With that exact apparatus on
we could
Earth.
change it. We could use a cargo van with a helium balloon. We could change the medium. We could change the objects inside. My point is, when you accelerate from being at rest, the matter will always.
I would deny that is not a constant. No.
So you would deny that matter.
The gravitational field is strong enough, such as in a black hole, that light can't.
So now we're
escape.
going to imagination land to explain your.
We've captured pictures of black holes actually,
Okay.
and we can measure them
Right.
and see them with telescopes.
I think we're nobody's ever going to reach an agreement because we have different ways of.
So you
informing
deny
our
that
beliefs.
accelerometer exists on Earth? You're denying that.
I didn't say on Earth. I said that's not a fundamental property.
How is it not?
It's not objective.
How is this not objective?
It's
It always does
here
it.
in that container.
Yeah, and which means if I release this, because we're still here on Earth, it should be affected.
Can I
by it,
make
but
a
it's
point?
not.
Can I make a point? I think that your worldview is really dangerous because because you're limiting yourself and your understanding.
I would
of
say
the
you
world.
guys are doing the exact same thing you're telling me right now.
I'm saying I think your worldview is really dangerous because you're encouraging people to limit their understanding of the world to what they can only experience.
You're doing that, and you're replacing theories with practicality. You're doing that, and you're replacing theories
we would
with
regress
practical.
scientifically millennia. And I think that's a really shitty way to look at the world.
I would
because,
say
because in our
that's just an appeal to authority. What you're doing.
It's not an appeal to
Yeah.
authority. at
Well,
all.
so many people did it before me, so I don't have to do it myself. That's just an appeal to authority.
It's an appeal to the progression of humanity, as in all the things
Appeal
we
to
have.
authority,
So,
I mean.
so let me get my point out. All
Sure.
the things we have today that are life-saving, that make our quality of life so much better, such as light, medicine, electricity, gas.
I don't deny none of those things.
All of
Sure.
these inventions, all of these things that just make our life exponentially better and have
I
pulled
agree.
humans through the throes of shitty living, right? All these things
Sure.
have arisen from scientists who wanted to observe phenomena in their real, objective reality. And in doing so, they needed to observe things that they couldn't necessarily tangibly feel. Your worldview necessitates a world without any of these phenomena, without any of these inventions, because I guarantee you that if Newton was alive today, he would look at Albert Einstein's findings and he would say, "Son of a bitch, you guys have beautiful instruments that I did not have access to in the 16th century. Props." And I believe your view, and I accept it.
Every piece of technology, I agree, it comes from understanding principles. You understand principles, this happens because this happens, and that's how we advance technologies, is by understanding basic principles, and we build on those principles.
Yes.
The globe Earth starts from a false premise. That's the point.
Yeah.
Just because the globe Earth is a lie and downwards acceleration is a lie, that doesn't mean every technology is a lie. I agree with technology,
Okay.
yeah.
My last point before I go.
Yeah,
because
sure.
I think I'm just as likely to change my mind as you are. But my last point
Sure.
before I go is that I don't believe that your theory of gravity is aimed at explaining A, the fundamentals, or B, as many different principles as possible. Because I've asked you to explain how light
I'm gonna say that had nothing to do with.
explain the atomic clock and time dilation experiments we did.
What is
with-
time? Let me ask you, what's time?
What's time?
Yeah, what's time?
Yeah, that's an extremely.
I can tell you what time is.
Okay, tell me what time is.
It's a concept based on the motion of the sun.
It's based on the motion of the sun.
Yeah, it's a concept. Time is not a real thing.
Time is not real.
Yeah, it's a concept.
Okay, then we get into pretty.
That's what I'm saying.
Like abstract. you
The
get
fact
into
that
pretty advanced
Einstein.
principles.
Well, that's just.
You
That's
don't
the
have
reality.
to do that for this
But
argument.
you're a reality observer. If you experience this car go from there to there over in progression, you actually as a human experience time. That's what aging is. If you're denying time, you are a reality denier.
I'm not
So you
denying
yourself
time.
to say.
I'm not saying. I'm just saying that it's a concept that we created as humans.
So it's a real thing. But if it's a concept, it's a real thing.
It's a
an argument
concept
to
based on
make.
motion. Yeah.
It's not based on time. Okay, time is.
If we didn't
not
have the
independent
sun
of- no, time-
or the moon,
no,
how
I
would
agree.
we tell time?
Time.
Oh, we would age. Our cells would grow. Our time is completely independent of the sun and moon. Time is
Yeah,
universal.
time is independent of sun and moon, but it's tied into motion. And if you want to get into that, that's Einstein's theory of relativity.
Okay.
Motion, time, light, right? Okay. I think you would benefit greatly from picking up Einstein's theory of relativity, right? Special and general theory of relativity.
Right.
Understanding what he believed, his thought experiments, taking some math classes, and understanding the math. I think that would benefit you greatly.
All right, sure. I would say that's your opinion, and yeah. All right.
All right.
I mean, anything
I
else?
think that's it. That's
Yeah.
all I got.
All right. Appreciate it, man. I appreciate the chat, man.
Yeah.
I appreciate that.
too.
Okay. Okay. You guys wanna? Here, you guys could take my flyer. I go to other
I'll take
universities.
the flyer.
Yeah.
I'll take the
Here, I'll
flyer.
give you one too. This is here. I'll give all of you one.
Alrighty.
Here, I'll give you one more. Last one.
All right, give it to Brandon.
Yeah. Thank you. All right, man. Take care. All right, you too. Alrighty. Oh, it went a little longer than expected there. Yeah, so, yeah. I mean, one of the guys came back. He brought his physics friend, I guess, right? And, yeah, I guess he gave it his best shot, but... All right, that's going to be it for this one. Again, thanks again for everybody that showed up, everybody that comments, that sees my videos, that shares them. Thanks a lot, you know. Yeah, I guess that's going to be it for this one. And see you guys on the next one. Peace.